to session number 2. We'll start this a little bit early, but I think it's good to get a little bit of an intro of what this session is for, what we're going to try to cover in this afternoon. This is going to be monitoring for infrastructure and for construction purposes. And so we have Roland Chen and Apeksha. And I didn't catch Apeksha's last name. I would have had to write that one down as well. I'm going to let you guys introduce yourselves really quick. Again, if you could, just everybody, there's quite a few people already online as well. And so, and maybe just kind of your take on just what your agenda was going to be. Then we can go around the room after that.
Yeah, hopefully we can give some information that you guys can use today.
I guess my name is Roland. I'm on the monitoring sales team. Been there for the last 3 or 4 years. Before that, I was on the monitoring support team. So I have a fair amount of experience kind of in the field, in the office, supporting monitoring systems, implementing monitoring systems. The goal today is to really get you guys up to speed on what Trimble has in the monitoring portfolio, and really a little bit more about how it works and how it can be used in the construction space. We have a presentation focused on rail monitoring in particular, because I think that's a big growing industry for, especially out here as high-speed rail comes in and freight needs a lot of maintenance stuff. But we have a lot of stuff in our back pocket, so we're happy to kind of pivot and talk about other things too. So we have one focused on dams, so we have enough time to kind of take a look at it. The goal is to really have this be more of a discussion and like a big roundtable, because you guys have all the field experience. We know about the technologies, so we're trying to bridge that all together and make sure we can get them out effectively and give you guys some more tools to go out and use. So feel free to interrupt at any point. We're more than happy to talk about any technologies in particular. If you guys have questions on specific workflows or projects, please stop and do that.
Yeah, that's really what I'm hoping for, is that you guys can come with some specific questions about some monitoring challenges that you might have, even if it's not relative to rail or something that Roland's talking about. Let's talk about those things. That's really why he's here. So sorry, Roland and Apeksha both. So let's just go ahead and start right here with Heather, and just kind of introduce yourself, who you work for, and what maybe you would like to see in this afternoon session.
I'm Heather Butler. I'm with Meridian Engineering. I'm on the construction side. We have done a lot of railroad monitoring. We do monitoring of, buildings that are too close to the site.
Mhm.
They're worried about that. We've done monitoring like that. So we're looking to, anything that would help it go easier and better, and new tricks and new techniques, because it's something that is always changing, and there's got to be a better way to do something sometimes.
There usually always is.
Yeah. So we want to figure out the easy way.
Cool.
So when you guys are monitoring these rails and buildings, you're just measuring points over time with your Trimble access, your typical measurement
Yep.
routines and
Yep.
so forth.
Yep. And we've had several sites where we've had to go back out for like weeks on end to make sure that the rails don't change, things like that.
And you're measuring manually just over and over and over again.
That's how we're doing it. I know that you can buy the thing and set it up and do it, but we're not ready to, not yet, but we're looking at maybe options to leave a total station doing those rounds, but you gotta have a job paid for that.
Well, you're not something automated yet, but
Yeah.
but the access monitoring app might be a really good fit.
Mhm.
It's a lot cheaper. It's just gonna run in your data collector.
Yep.
Do a lot of this stuff for you.
Yep.
So awesome. Okay, Levi.
I'm Levi, also with Meridian, kind of Heather's trainee, so kind of just here with her trying to figure out anything and everything in construction.
Your job is going to be to automate everything. So.
He is the one that figures that out.
Perfect.
Yeah. Levi is Ryan's son. I don't know if you knew that.
Oh, no.
Yeah, Ryan, that was not, there's several Ryans in the room, sorry. This Ryan.
You're sitting in Ryan's chair.
Oh,
Your dad's chair, I should say.
We've actually got 2 of his sons working for us now.
Oh, no way. That's cool.
And the company's still in business,
Yes.
Nice.
which is not what anybody thought. So we're really changing trends here.
Yeah.
Okay, awesome. Okay, Fred, we'll let you reintroduce yourself as well.
Fred Hatcher, I work for QED Construction. We're based out of Reno. I came up here because I've actually used the T4D system before, like 4 years ago, and I actually got to deal with Roland over the phone as tech support. He was helping us get all the little quirks figured out.
And you're also still in business.
Yes, so still in business. Most of the monitoring we do is manual with Telestation and Prism. Um, Buildings, foundations, bridges, and currently we seem to be getting a lot of railway jobs where we have to monitor a minimum of 3 times a day for the duration of the excavation. So I'm hoping to pick up a few more tricks to add to our quiver back in Reno.
Yeah, monitoring these rails, I've got a lot of questions how you guys are doing this. These different companies, where you measure on the rail, using what techniques, so feel free to share about that stuff. Compare some notes. Okay, good. Thank you for that. I appreciate that, Fred. All right, Clay.
Clay McFall, I'm with Salt Lake City Public Utilities. Just infrastructure monitoring of dams mostly. I do some monitoring of some of our facilities, settling of our facilities, because we have stuff out out in this marsh where nothing stays where it's supposed to. But then everything else is underground, so I can't do much about that.
Gotcha. Underground, like utilities, tunnels and stuff like that.
Yeah, pipes and yeah,
Nobody's going down in there, I guess.
and some of them, yeah.
There's some big pipes.
There are, yeah.
So on these, are there like water treatment plants, that kind of stuff?
Usually, most of them are sewer lift stations.
Oh,
Now we have we have 4 gigantic sewer pumping stations because of the prison and the port. And since they're all built west, they build the water table high and they move.
oh, yeah. So the prison is sending their sewage to the main treatment plant, so which is uphill probably, I don't know, it's got to be what, 50, 60, 100 feet,
So
something
it's
like
even
that.
worse than that. They didn't pump it all the way to the treatment plant. They pumped it to overloaded trunk lines over here.
So they're still figuring that out then. Right on, yeah. When they build that prison out there, I'm like, there's got to be some logistical challenges out there. All right, good. Ryan?
I'm Ryan with Foresight Limit Survey. Yeah. Buildings, hotels, highways.
Everything.
Yeah. Not mines.
Yeah, everything but lines.
Okay, good. Thanks, Justin.
Surveying. Haven't done much monitoring of anything. I'm just here to observe.
I'm Christensen Roadrunner Surveying, just here to learn something new about different things. I'm kind of limited with monitoring experience, just on settlement platforms on bridges being ready to build. Same type of stuff on dams. That's about it. So,
Do you guys ever need to do any monitoring on any kind of your road projects that you've done over the years?
just like when they build a bill for a bridge, they don't do it as much anymore, but they would surcharge, sometimes put with trains in and they put those settlement platforms and we monitor them for elevation to track how much the bill is settling, because they don't want to build a bridge and then have the approach be, 2 feet below it. So it's that kind of stuff. So that once or twice a month and bring those numbers in until they
Okay,
decide that it's done settling, or they're ready to build a bridge.
gotcha. So you're just doing topos basically of those approaches, those ramps.
So they actually install platforms in the field, so they pull down the material, that type of stuff. So
Hmm.
that's pretty much all we've done, and then like what we talked a little bit earlier, it'd be kind of nice if some of these new projects we've been doing. Nice to kind of see how to monitor movement of the components and that kind of stuff. You probably tell us a lot. Going on the site.
Can you tell us anything about the INL project where?
Yeah, so we're working on a nuclear facility up in Idaho, and one of the things I've noticed, I kind of came in halfway through the project, but this there's a lot of steel work, but all the bolt patterns and stuff are poured in concrete. One of the things that I noticed seems to be going on is with the temperature change, the concrete seems to be expanding and contracting, and gaps in concrete are getting bigger. Kind of became a big issue for a lot of people with the bolt patterns that were there. Now all of a sudden don't look like they're gonna fit the steel because of anything. So it kind of nice to know that, you know, how much of that's really going on,
Yeah.
be able to quantify it. So I imagine this probably be something to help with that.
Mhm. Right on. Okay.
Sweet. Well, thanks for the intros, everybody. Oh, people online, thank you.
Yeah, we have quite a few extra people online here. Hopefully everybody can hear us okay and you can unmute. We'll just go down the list here. Andrew Hakas, I hope I'm pronouncing that okay. That ding means yes. Andrew, can you hear us? Okay, we'll come back to him. Chad Anderson, are you there? No. Hal, are you still there?
Yep, I'm here. I'm from UELS in Vernal. Thank you.
UELS does. They're a gigantic engineering firm. They've done everything from dams to pipelines to power lines to all kinds of mining improvements, all kinds of stuff. So they've done it all basically. I'm kind of skipping over the Monson personnel here and the SciTech personnel. Brandon, do you want to introduce yourself? Brandon Knight?
Sure, Brandon Knight, Granite Construction. Just listening in, see what new technologies might be out there.
Okay. Sounds good. Steve Lloyd?
Yep, Steve Lloyd, also with Granite Construction. So excited to see what you got.
Yeah. Make sure that if you guys have any specific questions that you would like to see addressed, at least in theory, or maybe even in a demo, just make sure that we bring those things up. Martina Nelson?
Hey guys, can you hear me?
Yeah.
Great. Kind of same as Brandon. I'm with Park City Surveying. We're a small private land survey firm in Summit County, and I'm just interested to see the new tech out there. So I really appreciate you guys doing the virtual because it's hard to get down the valley during the work week. So thank you.
Martina, I'm so glad to see you on here.
Thanks.
This is so great. Okay, cool. Let's see, Phil Christensen.
Hey, how are you? Can you hear me?
Yeah, we can hear you, sir.
Great. Yeah, Phil Christensen, Flint Surveying. We do a lot of monitoring projects. So just interested in seeing the software and advancements and see if it's something we'd be interested in and maybe change our mindset of how we do things.
Awesome, perfect. And Sean Ireland.
So Sean Ireland, I'm with Meridian Engineering as well. I'm the construction project manager. Also oversee all of our monitoring and stuff like that, mostly on rail and buildings, like Heather said. So we're looking to expand it, and because I know there's a couple companies from out of state that come in with their, remote setups and everything, seeing what we can do to keep that business in state.
Remote sensing. Okay. All right. I think that's everybody. Unless Chad or Andrew came back online.
Yeah, I'm here. I just had my mic off before. I'm Andrew Hawkes from Dowell Engineering, based out of the Reno office. We do a number of smaller monitoring projects, usually as built after the fact. Right now, we've got a large settlement project going on, and in the past we've done a number of dam projects, dam monitoring, during flooding stages out here in the Reno area, believe it or not. Experience in a number of other projects, but looking to see what the new technology is and how it's being applied by other people, and recommended practices, and see whether we can up our game.
Awesome. Thanks for that, Andrew. Chad?
Yeah, can you hear me?
Yes, sir.
Chad Anderson, Element Land Surveying up in Heber. I'm here because Troy invited me to come here, so I'm just here to learn.
That's probably the best reason we've heard so far, actually, Chad. Appreciate you being here and taking some time. Really do.
bet.
Can you guys see Roland's online, the online people? Can you guys see anything?
Now
Okay, there we go. All right, sounds good. All right, guys, I think that's everybody. Hopefully you have a good path forward, and make sure we give some good information to these attendees.
Yeah, for sure. Thanks everyone for coming. Appreciate everybody's time. I know it's a lot to get the whole afternoon with all of you, so definitely appreciate it.
There is going to be a little bit of repeat information for people who are here this morning, but for the people who weren't here this morning, hopefully it's all good new information. So I'll just be going over construction specific applications for our specialty geo products and solutions. So today's kind of agenda it's relatively straightforward. So I'll be going I'll be getting into what monitoring is, then what monitoring looks like in a construction setting, and then I'll talk about what monitoring looks like in specific application types, and then I'll be going over some success stories for some customers. All right, so what is monitoring? You can kind of, I'm sure everybody here has done monitoring in some way, shape or form. So when you survey, you're measuring things once, versus when you're monitoring, you're measuring something again and again over a period of time. And you see if there's been any sorts of changes or anything that you need to know because of history. So more technically, monitoring is identifying the displacement or the deformation of a structure, an object, an area. And then this data that you get from monitoring is then used to see if any action needs to be taken for a project. So in construction sites, there's constantly something happening. You know, there's big movement, whether it's excavations, moving heavy equipment, or the actual building of the construction site, of the building structure, and all that. So a lot of movement, and the after effects of all this movement and are not only within that construction site bubble. And depending on the scale of the site, its effects can be pretty substantial. And so that's where we come in. I'll get into what we do a little bit later. It's still pretty early. First off, I'll go into why we need to monitor in the first place. So let's take a look at some disasters that have happened in the past and how monitoring could have prevented it. So in 2007, the interstate, the 35W bridge collapsed in 2007 over the Mississippi River. In 2023, last year, there was a massive sinkhole in DeSeta, Texas. Hopefully I said that right. In 1976, there was a Cheatham Dam failure. And so these are all examples. These are very few examples of many that have happened over the last however many years, over the last 100 years, where there have been big construction projects going on, and it wasn't properly taken care of. So with the context of those disasters in mind, why do we monitor? These disasters represent where monitoring systems could have provided insight to the operators, the project managers, and any stakeholders for that project before any critical failure points. Monitoring, first and foremost, is for safety. Safety for workers and safety for the public. In addition to safety, if failure can be predicted, there can be actions that can be taken to prevent that failure from happening. And that way you can reduce costs of building, repairing, as well as any liabilities. Finding these trends within movement can give a lot of insight into the structure's health. So for example, the expected lifespan of a concrete structure before it falls. And so this is related to the managing of the risks that are associated with any infrastructure. All structures have an inherent level of risks, and having the right data can help owners manage these risks and take actions to mitigate them. And with all this being said, decision-making is made way more efficiently when you have real-time data for displacement trends, and also when you have this data at the right time and in time. So we have two major categories in monitoring. So we have the semi-automated systems, where you more so use semi-automated systems for subtle, so for slow, subtle movements like land drift. The area or project is serving once a day, once a week, once a month. You don't have to do it too quickly or suddenly. But automated systems are often done for when the safety of life and critical infrastructure is involved. So for fast or sudden movement, and the area needs to be monitored multiple times a day or at very specific times of day, needs to be very accurate. So I'll quickly go over system components, and I'll go over some system components in a little bit more depth later on. But so for hardware in a semi-automated monitoring system, of course, you're going to need prisms and a total station. The type of prism and total station typically depends on the application, the size of the site, the accuracy that you need. For software, you typically use the monitoring module in TEC to create the design to do pre-survey work and post-survey work as well, depending on what you use it for. You can use the Trimble Axis monitoring module for field data collection and also in-field processing. And you use T4D, which is Trimble 4D, to analyze and present your data in a meaningful way. So in automated monitoring, there's a couple more moving parts compared to the semi-automated system. So of course, you're going to have your prisms and your total station. And you're also going to have your M1, which is sort of a router, but it does a lot more work. So it manages and controls your total station. So you don't have to constantly, aim your total station to every target every hour, or however often you do it. And then it sends all that data back to T4D. And of course, you're also going to have a place to place the M1. So in an M1 cabinet, place to set your total station in the housing, place to have all your GNSS equipment and all of that. Some common sensors that are used in automated monitoring. So it's not just measuring positions. When in an automated monitoring system, you can measure water levels, the temperature, stress on planes, if cracks are getting bigger, et cetera, et cetera. So some common ones include piezometers, temperature probes, pressure cells, strain gauges, displacement sensors, and all this data from the sensors are connected to the data logger, which is connected to the gateway, which then sends all that data to T4D. And you use T4D control to process data and T4D web to show data to stakeholders, to turn alarms on. And we'll go over T4D a little bit later on because it is a pretty big and significant software and a really big piece to this whole puzzle. Yeah, essentially, that's where the sausage is made. So we get so much data and overwhelming amounts of data from all these sensors and tow stations and receivers. And we need a really good way to organize it all. And we want to somehow make this data meaningful. So T4D control, we can enable an automated movement and detect this movement, and also support informed decision making about the infrastructure. So you can manage your sensor data and how this data is being used at the same time as other systems in the site. You can also process the data both in real time and for post-processing. So using total stations, GNSS, and sensor data. You can also do a network adjustment of data from multiple total stations. And you can also, if there's a lot of data that you need to process, you can actually use several engines to process this real time and post-processing workflows. And you can do this all simultaneously to process the data in multiple ways. There's also a lot of ways to analyze this data, and T4D provides a super comprehensive way to analyze it all, and also to present that analysis and that data for people who may not necessarily do that analysis, but are involved with the results. Roland will be giving a short demo of T4D later on as well. And it's a super useful tool to both process everything and to tailor the viewer's experience to effectively communicate whatever it is that you need to communicate to the responsible parties. All right. So before I go into more specific detail, are there any questions? Do you guys have any questions, comments?
So I guess for people that have used or been doing a lot of manual monitoring, have you been mostly using just Trimble Access or SiteWorks and going through and measuring manually, just shooting points? What do you guys do for your deliverables there? Do you just put them in an Excel sheet and send them out?
Yeah.
Has anybody tried the Access Monitoring module? Would you like to? Everybody gets, there's a 30-day demos that come with all the Trimble Access licenses, so you can try out all the different modules. And most of the time, 30 days will get you through a pretty short monitoring project. So if you have something coming up, just load the demo on there. The Access monitoring stuff is kind of the most intuitive module to use in Trimble Access. Like, you don't need training or anything special like that. It just does what you hope it would do. And so I recommend if you have something coming up, just download it, throw it on there, use it for an hour before you go out there, just so you're familiar with all the buttons. And it'll run and just collect all that data for you without having to go and shoot all those sites manually. So it's a huge time saver.
Just to bridge the gap on that a little bit. So this is through the Trimble Installation Manager on your data collectors. So if the data collectors are online, you can run the Trimble Installation Manager. And this is what Roland was talking about. If you just look at additional modules, all the different modules will show up there. There's probably gosh, there might be 8 or 9 of them now.
That's a lot, yeah.
And so monitoring, you can just pick that there, and that goes for roads too, something else you might want to try out. And so, yeah, and you can get them on there for a temporary license. So,
does it have to be a TSC 5 or 7 now?
I think
no,
anything that runs
as long as it's Trimble Access.
2020 or later.
2020 or later.
Yeah.
Oh, if that's so.
Yeah.
So if it's a TSC 3, you might be limited there.
Okay.
Good reason to buy a data collector.
Oh, we got it.
So, monitoring in construction. So before I get into anything super specific, I'd like to go over a quick monitoring workflow for or like a skeleton of one at least for a typical construction site. So first of all, we figure out the maximum expected displacement, how much displacement is allowed, what is the limit. And this graph here is from a study done on how much soil moves depending on how many stories there are on a building. And engineers on the site can use research like this to base their displacement expectations on. And you can also create displacement expectations based on the typical and natural movement of the area or the structure as well. Then depending on what the allowable limit is, you can determine what your accuracy requirements are. So kind of what trim of equipment do you need, or what type of surveys do you need done. Then you get into the initial survey design phase. So what does the site look like? Where do your control points go? And before any work is actually done on the site, reference points they need to be permanently monumented outside the region of influence, which is the area that will be impacted directly from the construction area. And fixed monitoring points should be placed on the object or an area that you need to monitor. And this can be placed either during the initial design phase or when you're doing the data collection. So during data collection, you do the actual survey, and then you do a network adjustment, just as you would with any survey. And then you do the modeling of any deformation that might be happening. So is there any significant deformation happening? And this could be through Excel, which is very accessible, but it can be a little bit complicated. Or you can run this through a dedicated software program. So this is a screenshot from T4D. And all this data is automatically fed into T4D. And you don't have to move any USB sticks or whatever is used to load it into Excel. You can see that the two targets, the orange and black over here, they are for some reason moving way more than they should be. It should be fairly level. And so now we know, we need to check, is there anything happening with these targets? Do we need to, send out people to fix something on the site? Or is it just a target that moved? Who knows? We need to actually send somebody out there to check on it. And so, yeah, this is super useful for that. Then finally, the data is presented to shareholders and the people who actually make the decisions. Any action that needs to be taken is taken. All right, so then, why do we need to monitor in the first place? What is its importance? Firstly, we need to quickly detect the early signs of a structure's movements to avoid any disasters. So, for example, if there is an excavation or some kind of heavy construction work near a standing building, it's important to monitor the building's movements. So, especially if there's people in there. It's the responsibility of the construction site managers to make sure they don't negatively impact their surroundings. And once movement is detected, how can further movement be prevented? Usually more movement means more chances of a structural collapse. How do we prevent that? And it's much more expensive to reconstruct a site than it is to check for movements in the first place. Cost is one thing, but any drastic movements could also come with a potential loss of life. Properties can be damaged if a building or structure moves or tilts too much from its allowable movement. There's a lot of substantial repercussions that can come from it. So, as I'm sure all of you know, construction sites are extremely busy. There's always lots of people moving around, moving things around. Multiple tasks are happening all at once. There's equipment and material and dirt constantly being moved around. And because of that, if you measure the position of something on site at the beginning, that position might not necessarily be the position of that object the entire time. The consequences of that can be potentially drastic and even fatal. So if a nearby infrastructure moves and it's residential, then an evacuation needs to happen right away. There's a possibility of a collapse, which can cause injuries, property damage, death. If soil or something around or soil on or around the site move, then that means the infrastructure on that soil has the possibility of moving as well. Both infrastructure, like buildings and whatnot, but also trees and there's a lot of regulations that you have to follow for flora and fauna as well. This can also affect, or soil movement can also affect underground structures that you can't necessarily see. And so there are a lot of connections to soil movement. And if you don't detect movement in time, it can cause extensive delays to the projects, and it can even get canceled. So, or move on to the applications. Anyone have any questions about the importance of monitoring?
What you guys have been measuring out and doing your manual monitoring, have you found any big movements or anything in the data? Or has it all been pretty boring? Ideally, it's boring,
I
right?
did a landslide, a lot.
Oh geez, how much movement was it?
It was feet, multiple feet.
A day?
I think I was only monitoring it once a week
Okay, that's still a ton, yeah.
during a particularly wet year.
Got perfect application right there.
Yeah. Should have someone go out every week and do manually.
Did you mount prisms in the landslide and just go back and measure them, or did you choose targets and kind of?
We actually drove some rebars into the landslide and
nice.
just measured it with GPS.
Oh, I see. That'd be fun to go out there knowing it's moving that much and staying there and take a shot.
Were there utilities that were
Our water line is down a little bit lower. That's why we were monitoring it.
Mhm. Now I'll be getting into where we so we create monitoring systems for all sorts of application types, and our more general solutions can fit the bill for a lot of application types. So firstly, I'll get into excavations. So I'm sure you all know what excavations are, but essentially excavations involve the removal of rocks and soil and other materials on the construction site to prepare for building whatever it is that you need to build. Excavation is also very foundational for important and a stable and level foundation, and that pun is intended. So the removal of soil takes away a lot of structural support for the surrounding area. So that means safety is compromised. A lot of work is needed to ensure that either the surrounding infrastructure isn't affected, or some kind of shoring or supporting structure is added to the area. And bigger surrounding infrastructure, so commercial buildings or crowded infrastructure in downtown, let's say, also means that a greater force is exerted in the excavated area. So if there's retaining walls that are put in place to either prevent movement or as a fix for movement that has already occurred, you still need to make sure that the wall itself isn't moving either. And these are just examples of how a retaining wall could move. Excavation monitoring also ensures that the construction design can work with the current site parameters, because your initial assumptions aren't always going to remain the same. The design can also be accepted when monitoring models show that the extent of any failure is controlled by the additional support that was added onto the site, and that the support isn't overstressed, and that the displacements that were detected have been stabilized. And so when displacements are monitored, the predictions of the design plan can be confirmed. And last but not least, the structure still needs to be monitored even when construction ends. Any changes or risks that happen to the structure after construction is ended will need to be translated to the building owner, especially in areas that have unstable ground, or areas that have a lot of climate change or something, that, and it's not a very stable area. So now I'll get into structural monitoring. So what you're monitoring is structural health. So what is the structure's integrity, and is it safe to be on? Then monitoring it can identify and as well as mitigate any potential risks or vulnerabilities. So it provides data for informed decision-making during the entire process. So during design, construction, and also during the operation. What you're doing is extending the lifespan of the structure through proactive maintenance rather than reactive maintenance. You can monitor any structure that you need to know the position of by making sure it's moving how you expect it to. And you best believe structures will move, but you just have to make sure it doesn't move in the way that you don't want it to. So here the GIF, which is CAD software, not T4D, it's showing that even though the bridge is moving, you can see that it's all still blue, moving that it's moving as expected. And there are some parts, such as like the top part, some of the sides, it is moving a bit more, but it's not extreme, and no action needs to be taken. However, in this case, you can see it's moving way, way more. The bridge deck's movement is given, or is way over the given threshold, and it's going into the red. So this needs to be brought up to the right people to take the proper action. So what structures can you monitor? Well, buildings, bridges, dams, tunnels, heritage sites, basically any physical object can be monitored. So yes, you can monitor these, but what are you actually looking for when you are monitoring? So you're looking for deflection, for vibrations, for strains, for major temperature differences. Are the cracks increasing in width? What are the displacements? How is the load being distributed across the structure? So by looking at all of this data that's continuously changing, you're able to reassess risks and see how the conditions are evolving. All right, so now I'll be getting into the specific equipment that you will be needing for a monitoring site for construction. For hardware, you're going to want, well, depending on your deliverables, you're going to want geotechnical sensors. So some common ones include tilt meters and strain gauges, an inclinometer, but again, that depends on the site requirements. Typically, you'll also need a total station. So for monitoring, you usually use the S7, S9, or SX12, again, depending on the site requirements. And you can also use GNSS on your site. So typically the D2, R12i, or the ZESO3. For software, you typically use Trimble monitoring for when you're in the field, and for post-processing, either TVC monitoring or T4D control. And as for accessories, of course, you're in prisms if you use total stations. And if you would like to create an automated system, you're going to need a solar kit. If you don't have a power source that you can connect. So as long as you have proper sunlight in your area, you can use this solar kit to automatically power your monitoring system. And we can get more into that if you guys are curious, but I don't have that in my slides for now. So I'll talk about some other applications. I just won't go into depth about them. So for piling, essentially you prepare the ground to carry really heavy loads, whereas if you did pilot, it wouldn't be prepared to carry whatever load it is that you're putting on it. And it's a very, very highly skilled job. And there's a lot of moving parts to a piling job. So sorry, I lost my train of thought. What you're monitoring when in this type of project is you're looking at the movement of the pile itself. So what are the stresses on the pile looking like? Is it settling? Is it tilting? Is the design actually working? And you can calculate data from these sensors in T4D. So a couple of sensor examples would be strain gauges and accelerometers on the pile sleeve itself. Inclinometers for if it's tilting or not. Vibration sensors for surrounding infrastructure, because of course on a construction site it's not only affecting the site itself, the surrounding area needs to be monitored as well. So dewatering. So dewatering, of course, when you remove groundwater or surface water from a construction site, and or for excavations where water can't naturally flow out, examples like that. And this really creates stability for construction work. You can monitor dewatering systems by looking at site water pressure. And data from this system can also be used to determine the pumping rate at which the water needs to be removed. And piezometers are often used for this type of application. And lastly, demolitions slash blasting. And this is often done to break rocks for excavations on dams, tunnels, and road construction. So you need to monitor this type of application in order to make sure that all blasts went off as expected. You also need to identify the maximum vibration and air pressure levels that are connected to each charge. You need to evaluate the potential damage on surrounding structures. You need to reduce the intensity of explosive charges just in case if the vibration charges or if the vibrations and the air pressure levels exceed the thresholds that have been predefined. All right, and I have a question for you guys. Even if you haven't been using this type of technology, do you see yourselves using it? You know, is this something that you guys could potentially be using in your workflows?
What's
Got some people shaking their head to myself over there.
So it seems like it's primarily total stations that you guys would be using for the monitoring side, right? Is that it?
GPS?
Yeah, I mean GPS for the larger, for the landslide, and some of our dams do GPS.
Now, I'd imagine the dams have other instrumentation as well. So outside of the total station service side, but the geotechnical side, is that right? Do you guys do much with like piezometers and water levels and?
And yeah, they all have water. Well, not all, but yeah, they do have water level.
Mhm.
That was something that we're just looking at actually as a backup, because for some reason our water pressure thing doesn't work very well. But I was reading about using GPS multipath to monitor water level.
Whoa, interesting. How does that work? Now I'm curious.
Yeah.
It's a software, open software. It's post process, so it's not real time. I did see another guy did some real time stuff also.
Mm-hmm. And you're using piezometers to measure the water level, and that's not being reliable enough. Is that the?
I think it's fine if it's some of our people at the dam don't understand it.
Gotcha. Are they measuring it manually?
It's some sort of automated system, and I think that's the problem. Is maybe in the software or something.
Gotcha.
And there is a manual read, you can go read it, but it reads it, puts it into software, and tells them how much water, total water, is in it. And I think that's the problem. Is yeah, the height is always just fine. It's the how much water they think should be in it.
Oh, like the volume calculation or something is not quite being done right. Interesting.
I'd love to learn more about it.
Yeah, same.
That sounds really interesting.
On the construction side, so you guys are just primarily focused on the structural movement side. You don't do much with the underground side, the geotechnical side. It's always with the. Just good to know.
The same with the people online as well. Mostly structural work, presumably.
Yeah, mostly on structural. Now, I mean, here on site, you're not really piling in like steel beams like you were showing in your slide. The big rage out here are these aggregate piers where they'll drill down however many feet and then just ram a bunch of rock into it.
That's cool.
Yeah. Seen those.
Do you guys ever work with the geotech engineers on these sites? I'd imagine every construction site's gonna have a geotechnical team as in temporary on underground.
Usually you don't work directly with them sometimes.
Okay.
So the project manager is usually the one you know, kind of go through them. But they usually do pop up and have it make changes according to what they find.
What we've seen on the construction side is mostly it's the surveyors work independently and the geotechs work independently and deliver the data to project engineers or supervisors or something, and then they do something. So the Trimble monitoring stuff is used all over the place. And so we've been starting to integrate the geotechnical side into the survey side. The whole idea is that we want to make you guys essentially that point of reference for all that data. So even though you're only really, I don't want to say only responsible for, but your main function as a surveyor is to go out and measure the survey data. You can very easily automate those total stations and then bring in that geotechnical data and kind of show it all in one place. The whole idea with the geotechnical portfolio is it's not necessarily the sensors themselves. So the geotech engineer is going to have sensors that they plug in and use. The whole idea is that we have the telemetry system that goes on top of it. So like data logger is the way to automate all that data collection and then showing it all alongside that survey data. So then you would be kind of responsible for like setting up the automated total station and giving them a platform to then send the geotechnical data to, and it's all integrated in one place. Or you could be the people that just plug in the data logger into the geotech sensor. They configure all the settings and stuff, and then that's in the same platform. So it's something to keep in mind as you're working with the project managers and engineers and stuff. You float that idea there, where you say like, hey, do you want one system for it? And then you guys add a lot of value because you record the data automatically and host it for kind of everyone. This is the whole idea with the full side integration.
Okay, cool. So now I'll be getting into success stories or success story. I have one story in there. And if you guys want to hear more, I've got another one in there as well, just in case. So the success story that I wanted to talk about was in Newcastle, England. So there was a construction site happening, or construction project happening above a live metro tunnel. And so they needed to make sure that the tunnel underground wasn't being affected. So because the construction activity was happening above ground, the workers didn't really see what was happening below. And so while construction was happening during the day, there is no way to physically see how the tunnel and the people in the trains going in the tunnel, or riding the trains in the tunnel, were being affected, and if construction needed to stop if anything happened. So the purpose of this project, or at least monitoring the tunnel in this project, was to make sure that the construction activity happening above ground wasn't affecting the tunnel and the safety of the passengers inside the tunnel. So the tunnel itself had a cast iron ring lining, and so that meant the heat could trigger movement as well. And that is a custom built housing for the S7 total station. This next picture, because it was only surveying particular prisms within the tunnel. They actually created holes in the housing only for those specific prisms, and that's why it looks like that. But I thought it's pretty cool. So because this was a live metro tunnel, it was only accessible for a short period of time at night without any trains coming into the tunnel. So how were they able to execute it? First of all, during the design phase, they did a 3D laser scan of the tunnels so that they had the proper information to make an effective plan. It allowed them to pre-plan where to place the prisms as well as the total station setup. So their final solution consisted of a 1 second S7, an M1, they used T4D control for the post-processing and the back-end stuff, and a total of 100 prisms were used for within the tunnel. A temperature probe was also attached to the M1 due to, again, the lining being made out of metal, or being made out of cast iron. And M1 was actually configured remotely. So they didn't have to use any on-site staff. And it was all able to be done from the office. And that made the immediate use of the system. And it also removed the need to actually go into the tunnel, while the trains were running, and removed a lot of risk associated with that as well. So T4D was used to automate the alarms in the tunnel. So, in case any significant movement happened, the proper people were notified, and anything outside of the predetermined tolerances were noted. And the analysis charts and other visuals were super clear on T4D web, where they were able to see, what was going on in the tunnels, and made it understandable, and didn't, the people who were looking at the data, they didn't have to look at, all these columns and columns of, or rows and rows of data, but they were giving it graphs and significant ways to visualize what was happening in the tunnel without actually having to go in there. Yeah, so it's a very short a success story, but a success story nonetheless. And if you guys have any questions, if you guys want to see more success stories.
Does the M1 help you with the changing environmental conditions, like figuring the parts per million on the instrument and all that stuff that need to be used?
So there's no, the temperature probe can be attached to the M1, but the M1 itself doesn't have a sensor like that. It's how it, the M1 sends information to T4D or whatever software it is that you're using. And it also connects with it to the total station, and controls it and tells it what to do, and tells it to run at specific intervals, all that kind of thing. And it also connects to the sensors, if you have sensors, and it takes that data, takes all the data, and sends it to T4D.
T4D handles the atmosphere too. So it takes the temperature from the M1 and then the pressure from the total station. It does the atmospheric pressure for it. And so it does like round measurements and reporting and data, and then corrects it automatically. So you don't have to set up like other sensors and do all that. Same question.
So is there a check system to make sure that that total station that's that it's always checking into to make sure, kind of like check it back site? Is that happening with that, or is it just constantly going through?
It happens every single round. So the way that the automated systems work is that the total station's out there and it's installed and running 24/7. The M1 handles the temperature data measurement and the round controls, and it's got a built-in modem, so it just automates that whole setup. It's kind of like it's a smart controller, but it's not one that processes for you. So it sits out there, it collects all the raw data and stores it on board and transmits it back and forth to T4D. Every single round, it wakes up and it measures every single target in the order you kind of tell it to. Then T4D takes that information, and every round it'll run a new resection and spit out results on all the prisms for you. So you can set it up to have like all your backsides in there and treat the total station as floating or fixed, depending what you want to do. And then T4D has a million different like data integrity checks in there. And so if like a target's missed, it'll try to go back to the end of the round and remeasure it. And if it can't get it again, it just marks it as a missed measurement. If you miss a backside and your backside like geometry kind of changes and the results change, you can tell T4D to kind of know the error thresholds that it's looking for. And if you miss a backside, changes your results, it'll throw that round away. So that way, if you have really tight tolerances, especially on like a rail track or a building or something, it'll know kind of what you expect. And then if you miss the backside, results change. It doesn't send that forward, so you're not sending all the false alarms. And then it also can do like maximum expected displacements. And so you can say like, I want my alarms at 500s, but I want only to report data if that movement goes up to 6 inches or a foot or whatever it might be. Because if anything goes past that, I mean, something's happened to that data is bad, the instrument's damaged or prism's moved or something. So it'll know that value and then automatically reject any measurement that goes over it. So there's a lot of kind of checks and balances built in the whole system to make sure you're not just throwing out bad data every single time or reporting on bad data every single time.
What if your instrument would come out of level?
It would stop measuring effectively. So it'd still try to run the rounds, and then every time it goes to the prism and tries to measure, it knows that the compensator's out, and it won't report a measure. And so we have things in the portfolio like it's called an 8012. It's an auto level. And so if the site's like super far away and it's a pain to get to the total station, you put an auto level on there, and it keeps it within the compensator range up to 10 degrees on either side. And so it'll keep it super level even if it goes way out. Granted, you don't want to install your total stations in an area that's like always moving and totally crazy, but if it's like 4 hours away and you can't get to the site, and it's in that zone of influence, it's just a nice little safety measure. Like, okay, even if the total station shifts, I don't have to go to the site. And you can check all this remotely too. So the M1's got like a built-in web interface. So you can log into your total station remotely and check the level and open the camera and zoom around and target and stuff. So it makes that site management a lot easier. It's a great system.
Mhm.
It works really well.
Does it have to be used with a S7?
S7 and S9, the most common ones. Please. Okay. We always recommend the S series total station because of the find lock feature. And so it'll technically work with most or all Trimble total stations. And we can plug into Leica total stations too. So if for some reason you guys have old Leica stuff sitting around, we can plug into them. But the S7 and the S9 are the most common. And it's the ones that we like test and sell all the time. So we know that they work 24/7 and have all the features and stuff. You don't need a robotic one. Auto lock is so fun. And so if you're using, like if you have a project coming up and you want to get a new total station for it, and you're going to use that total station afterwards, you get the robotic one. But if you're using a dedicated monitoring instrument, you get the auto lock variant. And that way you don't have to like pay for a radio and stuff. It just sits out there and runs it, does its thing. A typical ROI time for a monitoring system like this is usually like 6 months to a year, depending on how frequently you're measuring and yeah, basically just how frequently you're measuring, how many prisms you have and stuff like that. And so if you know it's going to be out there for 6 months to a year and you're buying an instrument just for the monitoring system, you can just get the auto lock one and save a bunch of money. Or rent one from Monson too, like one of those guys rent total stations.
You guys want the issue, Mike?
Yeah, I'll take it. So now we'll kind of transition into the rail side. And then I hope we have enough time to go through some dams too, because it'll be good for a bunch of different stuff. So I'm adapting a presentation that's really focused on the T4D Rail Module, but it covers a lot of good stuff on the rail portfolio in general. So I'm not sharing. I don't think I'm in the meeting. So our team covers all of the monitoring stuff. We also cover a lot of the specialty solutions, so the rail portfolio and the underground portfolio. I always think that the rail stuff that we have at Trimble is like the single best product that we make. It's like a great solution that's super focused on all the specific rail workflows. It's designed and built by a team in Germany, and the German rail authorities over there like guide the world on how rail is built and how things are spec'd. And so the whole idea is that it's a dedicated portfolio around track surveying and scanning. And there's an integration with the rail portfolio and with T4D, where we can do a lot of really particular deliverables around the world of rail. So rail is a huge growing industry in the US, especially with light rail and high-speed rail kind of coming in and being modernized and updated. And I think we'll see a lot of new rail projects here in Utah, Nevada, and kind of the Southwest. I think it's a good time to know about the technology and then be able to deploy it on kind of monitoring systems in the future. So I'll go quickly through kind of the why and the what around rail, and then cover kind of the whole idea of the track survey and scanning portfolio where you're doing a lot of these track as-built and kind of what those can be used for. And then we'll kind of show what that data looks like in complete monitoring system. So there's a lot of whys around monitoring rail. Rail is unique in the way that you always have to guarantee kind of that it's operational and can run. Just gonna change. My thoughts. So a lot of times there are needs for monitoring on rail because you're not just tracking the changes of the rail over time because it's prone to shifting. A lot of times there's going to be an outside influence on the rail itself, and the rail authorities want to keep those rails operating all the time. So it's really common that the rail's been there for a long time. It's totally fine. It's been undisturbed. There's no reason to be monitoring it. And then all of a sudden, there's going to be a construction project next to the rail or some updates on the railway, or they're building a new rail platform. And then you're going to need to monitor a section of that rail because of this other construction, because of this other influence. The rail authorities don't want to shut down. They want to keep those trains running, whether it's freight or passenger or high speed, whatever it is, because any shutdown is going to cost them, millions of dollars over however long, because you have to not operate those rails and then play catch up the entire time. It could be a huge disaster. So the need for rail monitoring is there. And we have a lot of different technologies kind of help answer those questions. When it comes to rail monitoring, what you're monitoring is also a big question. A lot of times when we see specs for rail monitoring in the US, it's really just driven by 3D movements or really vertical settlement. And so the what parameters you're actually monitoring aren't always super specific. A lot of times that spec can be really, really loose. But the advantage of the T4D rail system is that it gives you very specific outputs from your monitoring system, especially with total stations and tilt meters, around the actual parameters of the rail track, right? So we don't want to just measure for individual questions or individual data. What we want is to actually output really specific track parameters from the system itself. Most of the time, what we see for these rail monitoring systems, that the authorities ask for pretty rudimentary data. They want the surveyor to go out and measure once an hour, once a day, once a week, and just give a coordinate set with your displacements and your coordinates on the essentially set of prisms on the railway. Well, what's actually happening is those rail authorities are taking that data and doing their own calculations on it to see how that track geometry is influenced. And they usually start with the track geometry itself and understand what tolerances are in there based on the speed of the rail. And so if it's low speed rail, there's a lot of wiggle room, but with high speed rail and passenger rail, you have to be much tighter with your track geometry changes. And so that's usually the starting point they use to kind of determine their accuracy needs and their kind of threshold needs. Just to kind of quickly cover some of the specific rail parameters if you haven't seen them before. Can't, it's just the same as can't, but without the apostrophe. same kind of word. It's essentially the difference in height between the left and the right rail. This really has to do with the way that the trains turn and go through curves and stuff like that. So a straight set of rail, the cant will probably be pretty close to 0, but as those tracks turn and kind of you get those different radiuses, you're going to get different values of cant. And so it's important to be able to understand how that changes and if that changes at all. A rail gauge is the actual just distance between both sides of the rail. Everybody uses a different kind of gauge. Freight has one, passenger has one. It just really depends on who built the rail and what it's being used for, and even at some points when it was built. The international gauges are all over the place, and every country kind of has its own standards. The nice thing about the Trimble track survey and scanning in the rail portfolio is that it has all these gauges preloaded in there. And so it knows the standard set of gauges. So depending on what rail you're on and what kind of what you're working with, it'll know the gauge and know that standard width and be able to kind of report and measure to what it expects out of that gauge. The twist is maybe the most important aspect of the rail, because the twist actually guides essentially the speed limits and the usability of the rail itself. I sometimes have a hard time explaining what twist is, but it's essentially cant over a certain distance. And so if you have cant starting at one point that's maybe an inch from left to right, and then cant at another point that's 2 inches left to right, the twist itself is really the difference in that cant over that distance of rail. The higher the transit speed, the more tight these tolerances become on the twist. It's really the one that when you're on a train, you feel that shaking. It's because the change in the twist are there, and it's messing with the actual way that the train sits on that track, and it's very kind of noticeable. The need for developing a rail-specific module in T4D really comes from the European standards. What we've seen is that Europe and Asia in a large part too is really leading the way in developing high-speed rail and linking everything between cities and countries with rail systems. What we've actually found though is the markets for building rail in Europe and Asia are more or less saturated. And so there's less and less need for building rail. So what's happening is those companies are coming to the US and the US and Canada, kind of North America, trying to bring their market from Europe to the US and help develop the rail system over here. And with that, they're bringing the standards over. So even though the US standards are fairly far behind what's happening in Europe, because these companies like Dragados, for example, it's a big contractor based in Spain. They're coming over and building a lot of light rails. They bring with them their best practices and kind of their understanding of how to work these rail systems. And they are really used to working with stuff like this. And so even though we probably haven't seen a lot of these kind of rigorous standards for the existing rail projects that we've been working on, these changes are coming. So people are going to be asking for these really specific parameters out of the system more than they have been kind of in the past. The workflow in general is to really start with an understanding of the rail before any project happens. And so a lot of that comes from the track survey and scanning and taking a big as-built. A lot of times these as-builts will exist because a rail owner is going to have a general idea of what their track is and where it is, and just kind of some design. But most of the time, the actual rail in the real world doesn't match up with design in the office. So it's important to go take an as-built and kind of understand how that rail exists. Most of the time, somebody's doing this as-built thing, so it might not be you guys all the time as a surveyor going out there and deploying the monitoring systems. But know that there are tools for it. So if you see it asked for in the spec, you can very easily add that into your monitoring workflow. And it can be a piece that kind of integrates with this larger picture. After that, you go ahead and you install all of your prisms on the rail track. You can measure the rail manually with like a rail shoe or just a prism on a pole, but it's not quite as precise as doing like prisms on the rail itself, or using something like a track bar, which I'll show you in a second, that can kind of snap to the rail and just make it a lot easier to measure. So there's ways that we can really make sure that there's much more precise data being taken, even if it's just a pure manual survey. Next, you use T4D Rail. So you load in the as-built from the track survey and scanning portfolio, or even if they're taken somewhere else, you can pull that as-built into T4D, and then T4D all of a sudden will know that track geometry, and it can spit out all the prism offsets and all the calculations for you just based on your prism layout and your track geometry. Once the data is all set up and configured, then you can deliver stuff through T4D Web to your end client, and they don't have to see kind of how all this was done and how it was made. At the end of the day, they just get their parameters out of the system, and it's essentially just magic for them. So there's a whole black box that you guys help set up, and then they get all the data they need kind of automatically. So the way that the as-built survey works, this is what the track bar is. So in the rail portfolio, there's essentially two major ways to get the as-built out of the system. You're always going to use the same general workflow where you're essentially measuring the left rail and the right rail with a total station or a different set of sensors. And you're actually physically measuring that track. So the track bar is like the easiest way to get into the rail portfolio. The track bar with a combination of Trimble Access Track Gauge Survey kind of lets you generate those as-builts super quickly and really, really easily. With a robotic instrument, it's essentially a one-man survey crew, one-person survey crew, I should say, where the total station is tracking. It's tracking one of the prisms. You pick the bar up and move it and put it back down, and then you say measure, and then it goes prism, and then measures the other prism, and then you're ready and you pick it up, it tracks that same prism. Go to the next one and put it down, and you measure the other prism. Just kind of go and measure that way. It's a lot faster and a lot easier than using prism and a rod or a track shoe or something like that. It's a really, really easy way to cover a fair amount of distance. The track bar is maybe the best thing to use if you're not doing rail as-builting consistently. It's a fairly inexpensive solution. Comes with prisms. It's really easy to use. The track gauge survey app is fairly intuitive, and out of those things, you can get a really good as-built. The Trimble, the Guido system over here, the cart, is very similar to the track bar, but instead of picking it up and moving it, you actually just push it along the track. It's a much faster system, and you can spec it in with all sorts of other sensors and accessories. So instead of just prisms and total stations, you can use GNSS and IMUs and scanners and do all these really dedicated track workflows. So if you're in the rail world consistently, the Guido is an irreplaceable and kind of completely essential tool. If you have any questions, you can email me afterwards. We can do a separate kind of session on the Guido system, but it's a really, really good solution. That comboed with the Guido Office software lets you do essentially anything on rail. A really common workflow is you can put an IMU and a scanner on the Guido system and then push it, and the IMU auto locates your scan as you go. And then you can scan and do things like clearance measurements and tolerances. So especially after a rail update, you go through and you do an as-built with the IMU, And then the scanner goes around and checks all the things that are in that area. So if there's vegetation or overpasses, stuff like that, you do a lot of kind of clearance verification. So it's a really clean workflow. Skip this a little bit. So now with the rail monitoring system, there's essentially two ways to do rail monitoring. One is with the actual as-built from something like the Gato system or the track bar. We call that kind of the absolute workflow. And so what you can do with that is, so when you set your prisms out on the railway, you set them out in what's called the chainage. So essentially a pair of prisms that go down and you mount them on the sleeper or on the rail itself. The chainage is how essentially everything on that rail is referenced. So the chainage will be in locate or in respect to some distance along that rail. So you might start at chainage 10,000, then go from chainage 10,000 to chainage 10,040. And along that way, you'll have prism spaces at X spacing. In T4D, you essentially tell the system what the prisms are, then it automatically marks those chainages for you. And then it gives you output at different chainage locations, essentially. So when you do your initial setup, you set your prisms up in pairs as chainages down that track. And then the system kind of takes care of the rest of the calculations for you. One of the big advantages of having your prism locations and your kind of track geometry is that you automatically calculate your prism offsets. So one of the challenges with either automated or manual monitoring in a track system is that there's always some sort of offset between the actual prism and the top of the rail. And so when you output, especially coordinates, it's pretty unclear if those coordinates are the top of the rail itself or the prism or the sleepers. And so it can be a little bit confusing if you're just delivering a raw set of data to somebody. They might not know exactly what is being reported on. And your prisms aren't always mounted perfectly to the rail. And so even though you're mounting, theoretically the same way every single time you're going down, if you mount a few hundred of these things, chances are some of them are going to be a little bit off. And so when you report on your prism locations and your deltas and your changes, doesn't always give you a good offset from, or a good, estimate of what your rail is doing. So what T4D does is it automatically calculates the offset between the prism and the rail. And so you can very easily mount all your prisms in different ways and have no standard. And T4D would still be able to snap it and lock it to the top of the rail. So that way all the data that's coming out is going to be the actual rail geometry and not just the relative prism change. The other thing that it does is it automatically calculates your track geometry changes over time. So it gives you the actual change in the cant and the actual change in the twist, and not just the actual change on that prism data. So what people get out of the system has a lot more to do with what they're interested in seeing. And some people might want to see, the change in the vertical or horizontal alignment. Some people might want to see a change in cant or change in twist. And so being able to get all those data sets out of T4D and have it calculated automatically for you is a huge value add, a huge asset. It makes you guys, or sets you guys apart from the rest of the people out there that might only be doing manual surveying or automated surveying or just giving data on the prisms. You can output these really specific parameters with pretty minimal effort. The other way to do it too, so you don't always have to use you don't always have to use a fully automated system. So you can use data that is manual or automated in T4D. So even if the project doesn't require like data 24/7 or data every day or data every few hours, you can use Trimble access monitoring and set your survey up and record your prism measurements semi-automated or manually, and then load that data into T4D and get all the same calculations out of it. And so instead of having to do the calculations manually or outside of Trimble access somewhere, it's all kind of done for you. The fully automated setups, there are a lot of advantages to them, but they're not always required. So the goal with the fully automated systems isn't just to like automate for the sake of automation to get rid of somebody's job or add complexity where it's not needed. The whole goal is to enable you guys to go get more projects. Because if you're totally fine to go out and measure things manually, that is a good workflow and you can make money on the billable hours. You can give the client their data and everybody's happy. But the fully automated data lets you go and bid on these projects that are happening 24/7. They're happening for years and years at a time, where it's really not feasible to have a survey out there. That's where the automated systems really shine. So I'm just kind of skipping it. And on this one. So the two different workflows, or two different workflows in T4D. So there's the absolute measurements where you're taking the data from the Guido system and the rail as built and loading it into T4D. And then there is what we call kind of a relative system. So if you don't need the actual like rail geometry itself, if that's not spec'd in the project, you can still do all these calculations as relative calculations, still using an automated total station or a manual total station, and T4D just does those calculations for you. So you go into T4D and you essentially build those changes out and you give it like a pseudo rail track and a kind of a loose kind of starting set for the geometry. And then it will do your delta cant and your delta twist and your delta for the horizontal and vertical displacements without giving you the actual absolute value there. So it doesn't assume that it knows the track geometry, but it still gives you all of those relative parameters. I guess one of the advantages to something like that is that it's a much simpler workflow, and you can use other sensors along the way. And so if you need data 24/7, but there's not really the budget to go in and bid like, 3 or 4 automated total stations, and that's just going to be too complicated and too expensive to set up, you can go in and you can install tilt meters, because the tilt meters are much more inexpensive and easier to set up and don't require line of sight. They're typically just a simpler sensor for the maintenance point of view. And then T4D can take the tilt sensors, put them into the same calculations and give you the same parameters. So based on the chainage, or excuse me, the track gauge, it'll know the distance between the tracks. It'll be able to spit out a pretty good estimate for the change in the cant and the change in the twist, and give you some of the same vertical alignment stuff. Granted, it's all based on tilt data, so it's all kind of relative, but it'll still give you really good data out of the system. So if a total station is not required, if they're not asking for 3D data and vertical settlement, a tilt meter is a great way to go in and supplement data, get 24/7 data, and not have to have a server out there kind of measuring 24/7. There is a trade-off because it's tilt data instead of total station data, so you're not going to get pure vertical settlement. But maybe that's a case where you can go in and use the tilt meter data to kind of guide when your survey crews go out. The idea is that the tilt meters can be there running 24/7, giving you kind of an early indication of when things might be moving. And then they'll tell you exactly, okay, this section of the rail is under influence right now. It's moving more than expected. And then your surveyors can go out just kind of as needed and measure that one section and get much better data. So you still have that advantage of a 24/7 system. It's operating and running for you automatically, and your surveyors don't have to be deployed and measured consistently. And they kind of just go out as needed when there's this high risk kind of movement. You guys ever used tilt meters before? Have you seen them before? Maybe I'll change this real quick. And so the tilt meters are part of the geotechnical portfolio. And so kind of complementary to the geospatial side is the geotechnical. We find that they typically go hand in hand. So monitoring is always done either with survey data or with geotechnical data or with both. So almost every site is going to have multiple kind of sensor sets. So the whole idea behind the geotechnical portfolio is that it's very complementary to the geospatial side. And from a technical perspective, it's fairly easy to implement these sensors and kind of pull them into a single system. The way that it works is that we have our essentially data logger or sensor that runs in the field. The tilt meters have an embedded battery and tilt meter in them and a kind of a self-contained data logger. For other sensors, all you have to do is plug that sensor into the data logger and then automatically collects all that data and transmits it over. Each data logger is essentially an autonomous device where there's batteries inside of it, and it's got a long-range radio. So it sends data from the actual data logger in the field back to a single gateway location. The gateway itself has an embedded like 4G modem and Ethernet port and really acts as that big comm center. So it collects all the data from the geotechnical sensors on the site, gets it online and transfers that data over to T4D for further analysis and gets into the reports and alarms and everything. The advantage to doing it this way, instead of having like a more complicated data logger system where every single one has a modem or everything has a Wi-Fi signal or something, is that it's much lower power. And so these data loggers and tilt meters can run out in the field for anywhere between 5 to 10 years at a time, all on the internal battery. So it depends on the sampling rate a little bit, but that battery is going to last essentially for the duration of most projects you're going to encounter. That radio is super long range, so it can send data from the data logger back to the gateway over 9 or 10 miles. It's really in open air and good line of sight. It's just the horizon, so it's as far as you can see. In cities and in urban environments, it gets a little bit degraded because there's more corners to go around and there's just more noise, stuff like that. We still see signals going 1 to 2 miles at a time with little interference. So it's a really easy to deploy system.
Guys, I gotta step out.
Yeah, no worries. The advantage to a radio system like that is that it's super long range, and so you can cover a really large area. So especially on a rail monitoring project where you might have, monitoring needed on a rail for a 5-mile stretch, and you're monitoring at the key crossings along the way. You can have a single gateway with a bunch of sensors up and down that rail, and not really have to worry about that installation or putting that gateway somewhere where we can see everything. Makes it really, really flexible. On the geotechnical side, there's a million different sensors out there. So there's essentially a sensor that does almost any geotechnical parameter. So if there's a geotechnical parameter you need to measure, there's going to be a sensor that you can plug in for it. And we have a flavor of data logger that connects to essentially every type of sensor out there. And so if it's going to be vibrating wire or digital or analog, these are all just different communication protocols. You can plug it into the data logger and then transmit that data over to T4D and Trimble. You don't need to be an expert on the geotechnical world because those are going to be installed by the geotechnical engineers. All you really need to know is the name, make, and model of the sensor that's being used. We make sure that it's compatible with the data logger, and 99% of the time it is. And then we plug the right data logger into it and get that data transmitting. So it's a fairly easy integration and deployment without too much kind of like educational investment. You don't have to make yourself a geotechnical engineer. The tilt meters are really maybe the most intuitive sensor to use as a surveyor because they're measuring that surface change and that differential settlement and the differential movement. The advantage to a tilt meter is that it's not line of sight. And so you don't need a total station to actually be there and measure it and shoot that point. The disadvantage is that it gives you tilt data instead of 3D displacement data. So the one thing it misses is vertical settlement. So if your entire rail track were to just sink all of a sudden, you would miss all that data. Granted, that doesn't really happen in the real world. And so we almost always see some sort of differential settlement on there. And so the tilt meters are a great way to either supplement or replace total station data, especially when that budget is super tight. On the rail track, we have a version of the tilt meter that's got an internal antenna. The range is a little bit degraded, so it's not going to get that full 10-mile range. But usually on a rail track, you don't need, miles and miles of coverage. And so without the external antenna, I should say, it's a lot more robust and kind of easier to install and easier to maintain. So the idea is that you would put these tilt meters out there. You would essentially need one per rail tie. And then it gives you that tilt data, and that tilt data gets sent to T4D, and then T4D converts from tilt using that gauge to left and right rail kind of changes in geometry. So, any questions on rail monitoring?
How would you mount that to the tie?
It's a good question. So it really depends on the rail tie. Some rail ties are concrete, some are wood, and some are composite or something. And so the tilt meters, we have mounting brackets for them. It's essentially just an aluminum plate that screws to the back of the tilt meter. And then you can either epoxy or bolt those in place. A lot of times what we see on the rail track, because there's so much more movement, is that people will epoxy it and then bolt it. So there's kind of two, I guess, a redundant kind of mounting system. But it really depends on the structure you're mounting it to. You can weld it too, which takes a lot more effort, but thank you. It also depends a lot of times on what the rail people will let you do. Sometimes they don't want you messing with anything on the site, so you're not allowed to drill or screw into the rail tie, so it's epoxy only. Sometimes you can mount directly to the track itself. Usually you don't do that with the tilt meter because they're larger and kind of can be hit by the train wheels and stuff. But with the prism, they make these rail clips that just clip to the rail and then have a mount for the prism. And we've seen those work really, really well. So just every rail project is going to be a little bit different.
So Roland, when you see these rail monitoring projects over time, that what would that job, what would that project look like compared to what these guys have been doing, where they're going out just over time, just making their own measurements? I assume it's like in urban areas where there's a lot of construction, or maybe there's a lot of seismic movement or something like that.
Yeah, it depends. Every rail project is for different reasons. The most common thing that we see is either new track construction, especially expanding trackways. And so building a new track next to an existing one. A lot of times what we see too is local construction influencing existing rails. So especially utilities tunnels and retaining walls and new stations being built. And if those are being built next to existing railways, those have to be monitored. And so we call that kind of like a key crossing, where there's some sort of influence on that rail. And so you have to monitor, dense prism spacing over whatever structure is being built, and then a couple hundred feet on either side. And usually what you have to do is take a baseline for hopefully a few weeks before that project starts. It usually ends up being pushed out. And so it's really a couple of days before the project starts. And then you monitor for the duration of the construction, and then a little bit afterwards to make sure things aren't settled. We had a really interesting project in Canada that wasn't directly a rail project. It was actually the Trans Mountain pipeline expansion. So as they're building a pipeline through the Rocky Mountains in Canada, they crossed all these railroads. And so they were essentially using Trimble access monitoring to monitor the construction of the pipeline as they were going, because they just need to monitor for the couple of weeks during that construction phase and then pick it up and move to the next one. So they just have a survey go out and measure and monitor. And then every time they go to a rail track, they set up the automated system to measure for the month or two that they're in that area, make sure that rail wasn't influenced, and then they piggyback in or leapfrog it to the next one. And so they take the same automated system and kind of roll it down the project as across these sites. And they deploy, just a set of prisms, automated total station T4D, shoot it for the couple months that it's out there, pack it up and go down the track and move to the next one. So it's pretty interesting.
So those are the prism scenarios that are like clamping onto the rails or just movable, obviously. I mean,
those they just use them as consumables.
Oh, okay.
And so they just epoxy in place, charge the pipeline project for the few $1,000s for prisms, and then put down new ones in the next crossing. A little bit wasteful, but a lot easier than trying to deal with removing them.
I think the construction side is obviously what these people would be facing more often than not, just kind of like what you're describing versus the other possibilities. So
definitely, yeah. Yeah, it's funny when you think about construction monitoring, it's the site itself, and then also all those surrounding structures and all that surrounding area. A lot of times that's where the monitoring is almost more crucial than in itself. It's funny. Seen some glassy eyes, so maybe we take a 15-minute break, and then we'll go into dams, and then we'll do a T4D demo and then call it a day.
Awesome. Sounds good. These guys get some good questions coming up here. Okay.
I'm interested in figuring out how that software can figure out the spacing on the rails. That's intriguing to me. Because you put the prism on it and are you not measuring anything to the rails?
You would have measured the rails with the track survey and scanning stuff. So either the track bar or that Guido system. And so you're working in a real world coordinate system. That's like the one requirement for you can't necessarily just do like a local system. And so you push the
So you need to do that first.
Yeah, you do this first, exactly. So then you understand.
And then set the prisms.
Exactly.
Okay.
I guess you don't have to do it first. You can set the prisms and then do this. The workflow order doesn't necessarily matter. But you essentially, T4D knows the location of the left and the right rail. And it knows it as like kind of a big linear piece, so a big alignment essentially. And then because you know the position of the top of the rail and you know the position of the prisms, T4D can automatically calculate that offset for you.
Gotcha. Okay.
Yeah, good question.
What about for rail clip prisms?
Those are great. Yeah, the rail clips work really well.
They still work with this.
I guess the answer is yes and no. So yes, the rail clips work for a monitoring system. And so rail clips are a really good way to clip your prisms to the rail and get a really like consistent and tight offset between the prism and the rail itself. And a lot of times it can be easier to use that clip instead of trying to like epoxy or bolt something in place. And most people are totally fine with it. But you wouldn't necessarily use the rail clips for the as-built thing just because they're harder to move. And the track surveys or the Trimble Access Track Gauge Survey, like the app that you use to generate those as-builts isn't expecting like a clip on the rail. It's actually designed for the track bar or the Guido system.
Okay.
Does that answer your question online?
Yeah, because that's what we use, is we use the track bar, we clip them onto the rail.
Oh, the rail clip.
Yep.
Yeah.
And so then that's how we do our monitoring. But I was noticing with that software that you use, it says it can figure out the offsets.
Exactly, yeah, and that's how it does it.
Okay.
And this whole setup is fairly inexpensive. Like I don't want to commit to a price because I don't have it on the top of my head, but it's like maybe $1,500 ish for the track bar, and then the track survey and scanning app is a module and triple access. It's kind of priced the same as all the others. And so for a fairly low buy-in, you can have this workflow, and it might only take 15 or 20 minutes to run the whole 500-foot section of rail. And so if you're out setting prisms, you might as well take an as-built while you're out there.
Well, yeah. And we've had, this is for me and Sean, where they were putting a sewer underneath the highway and some rail at a critical area.
Yeah.
And we did not have the equipment to do the monitoring like that. But we ended up having to come back and as-built because they didn't trust the quality of the prisms. They were having some issues.
Oh,
so we were coming back and as-built and on top of that.
To verify the monitoring data. It's a really good way to do it too.
Yeah, and that would
this would save you a ton of time, right?
Oh yeah.
Yeah. It's kind of a good practice to as-built, monitor as-built.
Because it's getting exactly both sides of that rail.
Exactly.
Where I'm trying to figure out basically where I took that last shot. We're on the other side of the rail. So,
yeah. It's a huge time saver. That's what I mean when it's some of the best products in the whole Trimble portfolio. It's the simplest stuff.
I actually didn't even know about the rails, what he's picking up and putting back down. I thought there was the Guido and that was about it.
No, this is fantastic.
Yeah, this is way.
So is that something you guys sell?
They did.
Absolutely.
Yeah.
It's I've put the Guido a couple times and it's usually kind of cost prohibitive, but these look like they'd be way more.
Super low volume. Yeah.
Yeah.
You would buy it and forget that you ever bought it.
So there's one prism there on the left side of it. You have to give all the metrics of the rail itself. And you adjust the little feet on the rail so that they go on the rails, right? And then you just have those dimensions into your data collector, right? So it's actually able to map the rails based on
exactly. Yeah. It's a little bit simpler than that too, because it's one side of the rail bar has a T on it, so it can be like a right angle to the rail itself, and then the other side just has it's got a plastic tip, so you can use it on hot rails and not worry about shorting out the rail system. And it's got a spring-loaded prism, so it just snaps to the inside of the track. Trimble Access, the track gauge survey app knows all the track gauges, so you just input where you are and what type of rail you're on. It knows that gauge. You just kind of verify it.
The software,
the software,
the track monitoring.
Exactly. Yeah.
So you can do an as-built with the track monitoring?
You can not actually do an as-built with the track monitoring.
Okay.
So the as-built comes from the field data collection with the track gauge survey.
Okay.
And then the T4D Rail, that track monitoring, does your automatic geometry calculations based on the monitoring data.
So you also said that the standards were preset depending on the country and so that's the length of the track.
Yeah, I didn't know about that.
So it's I
That
guess how precise you need to be. If you know what the length is supposed to be, but then you're sizzling it.
So when you guys are as building those, where were you?
Put
Because
your route right on top.
Right on the.
I don't know what precision they expect.
Every ties or something.
It just depends on the job. I mean,
But it would tell you your.
this would have
And
been.
you paint the tie on the ones that you shot.
So what we did with that one is I just took the shot right on top of where the mirror was. Does that make sense? Because that's where they
Because they were monitoring.
monitoring a different company for that. But then we did the vineyard expansion. And that would have been, we just took in shots every 50 feet. That would have been a way lot easier.
Okay. How is that bar been around forever?
It's been around for a while.
And it's cheap too.
It's cheap. It's one of Trimble's best kept secrets. It's great. It's the easiest little accessory.
Because it's more consistent too, because that
It's super
rail,
consistent,
that
yeah.
rail has a little thickness and you're
Yeah.
trying to get to the center of it, but you're not consistently.
Yeah.
When you say it knows the gauge, don't you have to tell it what kind of rails you're using, and then doesn't it have to know the distance from the inside of the rail to the other, which is what the bar snaps to?
Yes, but it knows the gauge in the way that it knows what gauge to expect. And so when it generates the as-built, part of it, I think, is like the, I guess, gauge verification. And so like the gauges change by some amount, right? So there's a gauge that's like 1100 right, millimeters, 110 centimeters. There's one that's like 1300 and all that. So yeah, just depends where you're. For some people, I think the gauge is super important, but for others, maybe not so much.
But wouldn't the bar be measuring the gauge though because of the spring loaded?
It does measure the gauge, yeah.
So how would it know that if there's only a prism on one side of it?
There's prism on both sides.
Oh, there is?
Yeah.
Oh, so it shoots both sides.
It shoots both
every
sides,
time.
yeah. So it tracks one of the prisms as you go, and then you put it down and it measures, and then goes to the other prism, and then measures that one.
So
every time-
it is measuring gauge, cant, everything.
everything, yeah.
Okay.
So just like because the Guido has that like internal sensor that knows the track gauge, but this one just does with prisms instead.
Interesting. There you go. That's, I mean, the bar.
We want to avoid going on track at all.
Oh, so we need to get a scanner and then.
It's too hard to coordinate those rail guys to
Get access.
I love this one.
get access. I don't know.
They have to shut down the rail for you to be out there.
They have to be there monitoring.
Yeah, they have to have a rating.
Oh, and the flagger and everything.
Yeah, so that's what we're trying to help you avoid is. Go out
It's a
there.
pain.
We'll set up our total station. That's no big deal, but shoot at that. If we're gonna work out the track, then we have to have that guy there.
And you have to pay him.
Yeah.
Oh, the
We have
rail,
to pay.
I think you have to pay for 8 hours a day, even if you're only there for 5 minutes.
rail pros?
Yeah,
Oh, they make a lot of money.
yeah.
It's a good job.
It's a,
Has anybody else in here ever been threatened to go to jail by a railroad flagger?
Yeah. And if they fine you, you have to pay to fine your company. Can't.
Oh, it's a
pay it
personal
for you.
fine.
Yeah.
What?
So if Jeff sends me out on the track.
Are these guys related to the National Park Service or something like that?
they have,
They started in the mafia.
Yeah.
They act like they're.
they
Oh,
do.
yeah.
I think they probably did.
Who,
rail pros?
It's that they put
Yeah.
they put all the
No.
monuments along the rail line.
Uh-huh.
Yep.
So
It was a retired guy
benchmark.
from UP that started it. So they're in cahoots with UP.
It is mafia. So when you guys did your measurements, then you were, if you didn't want to get on the rail, you must have pre-mounted your prisms out there.
Yeah, and we run into that problem where there's like a road crossing and you can't see the side of the rail. And you can't get your total station up high enough
Oh, yeah, yeah.
to see down to the spot where you mounted a sticker or rhythm or whatever.
Okay.
And that's how most of ours have been.
Okay. So what do you do in those cases? Run out there and make the measurements? What's
I
that?
have to get real pro.
Pay him for 8 hours for the 5-minute job to go fix it.
Mhm.
Oh, wow.
And they're not cheap.
Have to build that into your cost, huh?
Usually it's the belly. But it's still fun trying to get that coordinated.
Isn't there a lot of rail out of INL? Don't they transport all their cargoes via rail?
Yeah,
So,
there is, we have been doing it with us.
Hmm.
There's a lot of roll on that thing,
oh yeah,
what they're bringing in is.
I-
Not real.
I imagine.
There's a track that runs through our town. They run on it once a week. And no matter what day of the week we go out on it, we still have to have roads rolling.
Of course, yeah.
Some surveyor got hit however many years ago and that was it.
Worse is when there's a monument you gotta go get, it's right in between all those tracks. You gotta plan UTA crossing that way so you don't get caught.
It seems like a real breakdown in philosophy here because we have light rail everywhere and there's people standing right there next to the rail all the time, running, hopping over the top of it, running across the bit. If we have to do some surveying, then we have to go through these lengths.
In Reno, that's the popular place for the homeless people to put their tents up. Right
On the
next to tracks. All down the tracks.
Oh, yeah.
Oh, like in the right of way and stuff?
Yeah, like on the track side of the fence.
Yeah.
That's fine, they just can't serve it.
He could live there.
You can have a home.
Not a job.
Yeah, that's crazy to me.
Orange.
That's that.
Right.
Look homeless that day.
Right.
So when you guys are monitoring on the roadways, do you monitor the roadway itself, or are you usually measuring just surrounding?
It's usually just setting up for bridges and stuff. They set up all that, and UDOT does a lot of, like if they've got a large field, they've got bid items for installing piezometers and settlement platforms and design where they're at. And we've only really dealt with the platform portion where we'll measure them and submit the data. And it's all just kind of like in Excel, for you to send coordinates and elevations.
Right.
I know Sean was gonna try to get with you, Troy, about
Analysis.
information.
And that's usually almost always on bridges. Yeah.
Yeah, that's pretty much the only place I've seen them, or if there's like a really large.
We just gotta get the job.
I think they're filling in a goalie or something, they got like 25 foot of rails and just kind of wanna analyze.
It looks like the cheaper option, instead of just using robotic, it's more cheaper.
It's not too many projects. But they're
About the bar.
No. Cause we've lost a couple, like, we just don't have the equipment to run. But leave the. Sounds like.
Auto lock.
The auto lock, but
Yeah.
without the total robotic is cheaper.
Oh, yeah. Yeah. Substantially. Right, the next section, we're focusing on this little guy. Can't tell? This is little or this is Mountain Dell?
Mountain Dell Dam. That was from a drone flight that I did this August.
3D print the, is this?
It's
The dam.
A little tiny dam.
I don't know if it's that tiny.
That's the one that's up at the top of the.
So I do have one that's actually printed to 1:600, and it's about a foot long.
Pretty cool.
Pretty cool. Blew it with your drone? Just photogrammetry or?
Just photogrammetry.
Well, you're not supposed to fly those things over dams.
I guess if you work for the city that owns them.
Well, the state is making it so I can't fly it over anything.
We have a short window.
Got a year before I can't fly it, period.
Yeah, that's a DJI.
Well, they did change the law at the last minute, made it slightly better. I don't know if you read it, but you can fly it as long as you are not connected to the internet. You don't connect it to the internet with the data on it. So we can't do network RTK with it, but could do either PPK or, base. I think with DJI, you have to use their base, and you can just use any base, can you?
No, you can use a Trimble base.
So can you?
You have to set up an N-trip socket caster, but they actually have a pretty good workflow and set of instructions on how to do that. So it's still over the internet, but a Trimble receiver will be the base receiver versus the VRS. So I don't know how that really helps you that much.
It doesn't help because you cannot be connected to the internet, period. That's.
Yeah, it's still through the internet.
You can't do that.
No matter how you slice it, you could even put a modem on the base receiver and transmit your corrections that way, but it's still over cellular. So maybe, it's still over the internet. So you still put in an IP address in there. So
Yeah.
Yeah.
I've done PPK and it seems to work pretty good.
Yeah.
Definitely been doing money. Yeah, and military. They do it old school way.
So I have to leave here in
Height standards or something.
45 minutes. So I'm just gonna leave everything running here, but I'll have to just say goodbye at that point. So
Sounds good. We'll stay after emails. We'll send one to everybody in the company.
Did you get my order?
I think.
Get my order.
no, thank you for the reminder. Oh, don't I get that? I have to do one other too. So
Sweet. Everybody's back and ready to go. Cool. So I'll take us through some of the dam instrumentation and monitoring ideas too. I know you do a lot of work with dams, obviously. Has anybody else worked on dams much? Okay, perfect. So I'm giving this presentation in a little while, so excuse me if it's a little clunky. So we'll kind of go through the life cycle of a dam, and really the idea is looking at where most of the work is happening for dams in terms of construction or building or new dams or old dams, maintenance and all that kind of stuff. We'll go kind of through where surveying is used on the dams, and I might skip through that section pretty quickly and focus more on the instrumentation side. So what sensors are used in the dams and kind of the job that they play. And then we'll be having a portfolio that really goes along with kind of monitoring for dams. There's really four main pieces of the dam life cycle. So we have the exploration and design, and this is really around building new dams. So it's really finding those locations where you need a dam and really determining a need for it. So it could be for reservoirs or flood mitigation. There's a lot of
Hey, Roland, excuse me.
Yeah.
Are you, do you have a different slide for dams? Because I'm still on tilt meters.
Perfect, thank you.
You got it.
Okay.
thanks, Mike.
Yeah, thanks to Miter. There's a lot of work that goes into the exploration side of dams. A lot of it tends to be remote sensing work and kind of doing these large scale, kind of big exploration projects. But there's also a lot of survey that goes into topographic surveys and really understanding like the nitty gritty details of when you're going to put a dam somewhere. Is it going to be in a good spot for the geology? Is it going to be stable? Is it going to do what you need to do? So there's a fair amount of work there. On the construction side, this is really where we go ahead and build the dam. So taking it from the design phase and putting it out in the real world. There's a lot of water diversion that happens with the construction projects. There's a lot of site prep that happens even before ground has been broken. And then once the dam is being built, there's a lot of work that goes into making sure it's there, it's stable, it's being constructed properly, and it's being built. On the operation side, this is going to be the bulk of the work that goes into a dam because dams are out there for 100, 150 years, 200 years at a time. And so most of the work that happens around a dam is operating and maintaining it. So making sure the reservoir stays at a good level. If the dam is generating power and you're making sure these generators stay up and online all the time, you're preventing flooding and you're kind of managing all those water levels and flood risks and things like that. And you're doing a lot of work to track those site conditions and really kind of guide a lot of that maintenance work. On the maintenance and update side, this is really where we're going to see a lot of new work happening around the dams. And so operating the dams is going to take a lot of monitoring and instrumentation. And then when the dams are updated and when they are kind of going through these big maintenance periods, there's going to be maybe a increase in the monitoring that's used or revamping of kind of the monitoring and instrumentation plans. That kind of happens and goes along as things are operating. So in terms of where surveying is used, so on the exploration, surveying is really primarily used, I should say, not in the exploration side, right? So in the building and the operation and the maintenance of the dams, there's very few kind of large new dams that are being built. A lot of the reservoirs that we have and a lot of the rivers that we have are already dammed to quite a large capacity. So most of the work that happens, we're going to see on the operation side, on the maintenance side, and on the construction for like replacement dams. For monitoring and instrumentation, is used for a lot of different reasons on the dams. The biggest thing that's used for, though, is always going to be that informed decision making. So we're going to make sure that we're taking data sets that make sense, so that way somebody that needs to make a decision can back that up with the right data. Sometimes the right data set's going to be total station data, measuring that displacement, that movement. Sometimes it's GNSS. Sometimes it's weather. Sometimes it's just a scan comparison of the dam face. Really, whatever data we have, we want to make sure that whatever question we have, we want to make sure that we're backing it up with the right information. You kind of have the right sensors on board to report that data. There's really three main reasons why, beyond that informed decision making, that monitoring and instrumentation is used on a dam. A lot of it is measuring the condition of the dam, and to make sure we understand how that dam is changing, how it's behaving, and what's happening to it, especially for preventive maintenance. More specific to dam sites, though, is really determining failure modes and tracking changes related to those failure modes. So every dam is going to have its own set of risks, and own set of kind of failure modes that can happen to it. These are just a list of the big ones. For people that have actually worked in dams, I'm sure there's a lot more that goes on behind the scenes than just these major ones. But essentially, all of these different failure modes have different factors associated with them, and we have different sensors we can use to kind of measure those data sets that go along with it. So measuring and monitoring a dam isn't always as simple as it might be on a construction site or on a rail site, or even sometimes in a mine, because we're trying to answer such specific questions about what we think might be happening to the dam. The common instrumentation that we have, on the geodetic side, we have the total station, GNSS, especially when it comes to the automated side. Those are going to be kind of the primary tools for measuring just movement. But there's also other tools we can use kind of in the geodetic portfolio, one of which is as simple as a visual inspection. Just having somebody there that can go and look at the changes and track what's happening to the site. We're introducing things like cameras, or what we can do too is sometimes we can take pictures using the total station during their round measurement to kind of track those changes over time. A lot of times, a monitoring system isn't going to be able to replace somebody that's going on site, though. And so most of the time, the monitoring data is used to supplement somebody that actually goes and tracks those changes and makes a visit to that dam periodically. Even with all the sensors in the world, it's still possible to miss some finite details. And so it might be as simple as, if you go to the site and you see that an area is wet and it wasn't wet there before, that's something that a total station or a piezometer or another sensor might not have caught. So we always want to make sure that we're using the right monitoring technique, even if it's as simple as having somebody go and look and inspect. On the geotechnical side, again, there's a million different types of geotechnical sensors, and every dam you're going to use a different set of sensors. The most common that we see, though, really are those piezometers, those inclinometers, and on concrete dams, those crack meters. They're really going to be out there to measure the water level change, a lot of times that subsurface movement, and detect changes in the cracks along that dam face itself, too. There's a lot of specialty sensors we can throw at it. So especially in areas that are prone to seismic movement, and for earthen dams, we want to make sure we're measuring that seismic change or seismic events, and also weather stations. So making sure we're tracking weather locally, whether it's going to be on the dam itself or even just up that reservoir, to make sure that any rain event up there isn't going to influence the reservoir level and potentially the structure itself. On the geodetic monitoring side, really what we're looking at is measuring all of that surface movement related to whatever failure mode might be happening. So the failure modes that surface movement is related to are really that toppling and rotation, the heave in the settlement, a lot of times that abutment failure and the slope failure. And we kind of think about slope failure for a dam in two different ways. There can be slope failure kind of on or near the dam structure itself that can erode the foundation that the dam is on and make the dam itself kind of unstable. And there's also slope failure up in that reservoir. So if you think about a potential landslide that's happening, upstream from the dam, if that landslide falls into the dam and hits that reservoir, it's going to push a huge wave down that reservoir and have some catastrophic effects on the dam downstream. And so making sure measuring all the surrounding slopes can be a really important part of maintaining those dams. A little bit more of a visual representation of how the setup goes on most dam projects. So with the total station, you have your total station set up measuring all of your measuring all the prisms kind of along the dam face. So a lot of times they're going to be on the crown of the dam. And then you have your back sites that are set up off the dam, so you have something relative to resect off of and get good displacements for. You can use GNSS sensors, and there's a lot of give and take with GNSS versus total station. GNSS is typically a higher cost deployment because instead of buying a single total station, you have to buy the 10 or 15 or 20 monitoring points plus the base stations that you're going to be using for your fixed base stations for all the corrections and things like that. So it's kind of more of a specialty application. The advantage to a GNSS system, though, is that it doesn't rely on line of sight and it can cover a much larger area. So a total station, the range might be 700 meters for a standard one or 2,500 meters for a long range gun. A GNSS system can have 35-kilometer baselines, and so you can cover a much larger area. So especially if you're looking at potential slope movement around an entire reservoir, this might be a much more feasible thing to deploy than a bunch of total stations or a surveyor going out measuring all the time. You can also get much higher data frequency out of a GNSS system. And so there's the real-time workflow and the post-process workflow, where your real-time data can be second or sub-second measurements, and your post-process workflow can be hour-long, 4-hour-long, 24-hour-long files. Real-time measurements, much quicker, but a little lower precision. So you want to use that for your kind of worst-case scenario alarming. And then post-process results, it can be much higher precision trends. Sometimes with trends comparable in accuracy to like a total station. And you can debate me on the ins and outs of that, but it gets pretty close. And so you can use that for a lot of your kind of long-term settlement data, long-term movement data, and combine both those together to have like a really comprehensive system. You can also combine both the total stations and the GNSS in T4D. So T4D can take the data from the GNSS system and take the data from the total station and report on that separately, report on it together, and just integrate both those data sets together and make kind of one big comprehensive monitoring system. On a lot of sites, not just dams, but any site in particular, especially the large sites, a lot of times it's not feasible to, or not possible, I should say, to install backsites in an area that is outside that zone of influence. So think about a big earthen dam or a big mine site or a construction site that's super confined in downtown in an area that you don't have good backsites. All those might be in that area that you think is moving. And so if you're running the resection off of those and those move, they introduce a lot of error that can be propagated into your foresights. So the integrated system, what we do is we install GNSS antennas on top of those optical prisms and use that 24-hour post-processing kind of data set to give you updated coordinates on your optical backsites. And then when the total station goes and runs that resection, it uses the most up-to-date coordinates. It is a little bit less accurate than just a standard total station setup because there is movement in the backsites and relying on that GNSS coordinate. It can be pretty tight, and we can get millimeter level trending kind of with the antennas. So it's a really good way if you expect kind of long-term settlement or potential influence on your backsites. You throw that system at it, and then it can be trusted and run out there. Granted, it is a more expensive system because you have to have your integrated total station with your GNSS receivers. So it's more of a niche application. But when it's necessary, there's really nothing that replaces this kind of a setup. I've actually covered it already, but there's also the semi-automated and the fully automated portfolio. So using either Trimble Access and Trimble Access monitoring and TBC monitoring to do your geodetic data, or that fully automated system that's got the total station and the geotechnical sensors kind of integrated all together. You can also use it kind of any combination of that in between. So T4D can take data from automated setups and fully automated setups and either import with like a CSV importer for all your automated geotechnical sensors. Or you can use a manual upload through the web page. You essentially just download an Excel sheet, throw a bunch of data into it, then upload it to T4D Web, and then it's integrated with all the other sensors. So if you have surveyors out there measuring a bunch of stuff on whatever intervals they have, they can just upload at their own pace and have that data integrated that way. So there's a lot of different ways to manage that data. On the geotechnical side, I always think about geotechnical sensors as measuring that subsurface data set. So very complementary to geodetics that are measuring surface movement. Geotechnical data measures the subsurface and a lot of times gives you the reason why something is changing and not just the result of it. Geotechnical sensors are used for essentially every failure mode because they can track those subsurface changes and really give you an idea of where that water is moving, how that structure is changing, how the surrounding area is changing. And because they're much more specific sensors, like a crack meter, for example, can give you displacements across a crack. You can deploy them on very kind of specific spots and areas around the dam. So the best monitoring systems I always think have both technologies involved and just kind of deploy sensors where they're needed, depending on what risks that data is kind of looking at. If you haven't seen it before, this is a good kind of way out of maybe the most common geotechnical sensor, not just on dams, but on really any site is going to be that piezometer. So piezometer is used to measure core water pressure. And so the piezometer itself is installed down usually in a borehole, and there's some sort of water level in there. That water level changes, and then the piezometer, all it does is really measure that water level over time. We plug the piezometer into one of our data loggers, and that's how we automate it and get it online. A lot of times the dams or particular other construction sites and stuff will have these sensors in place, and people will go and they'll measure it manually, or you guys already have existing data loggers. And so adding the data logger in is a really easy way to kind of automate that whole data collection, and then use that same technology that the tiltmeter has with that battery power and that radio to get all the data from the piezometer itself into the gateway and then into T4D for all that kind of automatic change detection. This may be an easier way to think about the in-place inclinometer or the IPI. It's a chain of tilt meters that you essentially install down a borehole. And because it's tilt meters at a fixed segment, you can extrapolate the kind of 2D movement and change in the shape of that borehole. Really, really common on earthen dams and for a lot of kind of high risk slope movements. But it's the same idea as a piezometer. These are already installed on most sites. And all we really have to do is plug it into the data logger, tell it how long those segments are, and then T4D does all the math for you and spits out a big chain of displacements. So a really kind of easy way to integrate that data together. The crack gauge, as I said, really just measures displacement across a crack. It's another fairly simple sensor out there. Most concrete dams and most structures are going to end up using it. Fairly simple in concept and in execution. You just mount it on both sides of the crack, plug it into a data logger, and then it records that data and transmits it for you. Again, just a quick visual of the way that it works. So we have the sensor plugged in the data logger. Data logger's got that battery and radio transmits to the gateway, and then the gateway goes and sends that data into T4D. Cool. And then just a few different project examples to make sure you guys know that we actually do work on dams. It's just not just a pipe dream that we have. So you can see this is the Victoria Dam in Sri Lanka. It's the largest dam in the country. It's absolutely gigantic. And they use a series of total stations and prisms to measure the movement across the face of the dam itself. And then they integrate with, I don't know if you guys can read, but it's almost 500 geotechnical sensors across that site, all getting pulled into T4D. It's been running since 2019 or so, which when I first started in this job was fairly recent, but now it's been running for a long time, and it's been a really successful project. The Tolt Dam up in Seattle. This one uses primarily GNSS to measure the movement of the dam itself. Then also integrates a fair amount of geotechnical sensors across kind of the dam inside of the reservoir. Something I think is interesting about this dam is the use of GNSS. And I think it actually kind of highlights how different technologies can be used for kind of the same application. So they could have very easily used total stations out here to get the same data that they're getting out of the GNSS system. The reason they went with the GNSS monitoring system is more to do with the comfort level that they have with the sensors. So the city of Seattle actually runs a VRS network, like a gigantic pivot network with base stations and core stations all across the state. And the guy that manages this system runs that network, so he's just very familiar with GNSS. So for him, it was easier to take some old receivers, repurpose them, put them out in the field, not have to learn a total station and learn a new technology, and then pull those into T4D. And it's just a really comfortable workflow for them. So really good data. The system works really well, and it's kind of just one of those, an interesting case of personal preference kind of dictating how the engineering is done. So as you guys are out and you're bidding on your monitoring projects, it's something to keep in mind. There's a lot of value in technology that's familiar and that you've used before. And then you can use that to kind of break into the world of monitoring. And then you can slowly add on other sensors and kind of build your own portfolio with that. The Sholbin-Skya Dam, if you're wondering how to say that. It says it's based in Seattle, but it's not. It's actually in Kazakhstan. It again uses the GNSS. This one, they're more worried about rapid movements because of kind of peak high waters from the tidal influence. And so for them, GNSS is used because of the data kind of reporting frequencies that they need, where they're not necessarily worried about the minute movements because they expect it to be moving a certain amount throughout the season. But they're really worried about all of a sudden if it shifts downstream a few feet or a few inches, they're going to be really, really, terrified, and they want to make sure that they can make the steps to mitigate all of that. The Stenbras Dam outside of Cape Town. This one is actually operated by our local Trimble dealer. They're contracted from the city to go and essentially provide a monitoring system. This is a really cool project for us because it's actually been a kind of development site in a lot of ways. And so they use total stations and GNSS and geotechnical sensors and T4D. And so we're able to take a lot of their feedback and kind of guide a lot of the deliverables that we have and a lot of the reasons, or a lot of like the different calculation sensors, stuff that we put into T4D. And they're also a big reason that we deployed the geotechnical portfolio in the first place. The dealer out there is a really good partner with World Sensing, who we use to manufacture and back us up on the geotechnical side. And so they were the ones that kind of built that relationship for us and brought them in and showed us how to work with sensors. And then we used a lot of their feedback, brought World Sensing on as more of a kind of in-depth partner. And now we have a much more kind of coherent system. So I think it's a cool example of using real world experience to kind of guide what we're doing and how we're deploying it. Do you guys have any questions on the world of dam monitoring? How did I do?
Be much nicer when my tape measure and go to the station.
I hope so, yeah. And as you guys have seen a little bit, I'm sure at this point, there's a lot of overlap in what sensors are used where. And it's kind of designed that way on purpose. Like we kind of, our whole goal is to help you guys get out there and get more business and be more successful through different technologies. And so we designed the whole system around being able to easily grow with automation, right? So moving from the manual sensors to the semi-automated side and then into T4D. And then once you're in T4D, it's really easy to add on other technologies. And so you can very easily start in the construction world or start in the rail world, and then take that total station, deploy it on a dam or in a mine site or on other construction projects and just grow, kind of add in these big specialty services. We've seen that monitoring tends to be more of a high value kind of service for a lot of construction projects and rail projects. And so it's a really easy way to kind of add into your own service and kind of grow your own business and build your own companies up. So we're here to back you up with anything else. If you guys want demos or have projects coming up and need to talk through them, you can reach out to Monson or myself or Peksha. I'm more than happy to get on calls and spec out systems and make sure you guys have all the tools in there. So with that, I'll get into a demo of T4D. There are a million features in T4D. And so if you guys have questions about anything in particular, feel free to stop me and we'll take a deeper dive into all the different tools. So we're looking at T4D Web. T4D again is split into two main components. There's T4D Server that runs the back end, and T4D Web that runs as the front end for all the deliverables and the visualization and the alarms and the reporting and everything. It's really where that data becomes kind of interactive and you can log in and view it as needed. The whole idea is that you guys, as the surveyors and as the monitoring experts, set up that back end the first time. And then you don't need to log back into it because it's just running automatically and doing that resection and checking all those things for you. That's not to say it's completely automatic and maintenance free. You do need to log in sometimes and touch it and make sure it's working and firmware updates and reboots and stuff like that. But the customers aren't really gonna, or your customers aren't gonna log in and see that and see how the processing is done. They're just gonna get this clean kind of end result that is the monitoring data all kind of aggregated and pulled in one place. It runs as a web application, or T4D Web does, and so you can log into it from a web page and kind of access really as needed. As I said, there's a lot of features in T4D Web, but it's all made to be fairly intuitive. So at first, it's going to look a little bit daunting with all the different buttons and some of the different options. But if we just go kind of top down through the site, it'll show you all the different features. I think it'll be a little bit easier to look at after a little while. So the easiest thing is maybe to come and start with the map view. And the map view is maybe the best way to get just a quick traffic light, quick status overview of the monitoring system. You can do things like turn on your displacement vectors to get a really quick understanding of what direction things are moving, and then turn on something like the heat map to kind of show you the severity. So especially if you're looking at a site that's got a railway where things are settling, and you want to show construction and show that there's only influence in certain areas, the heat map and maybe not the 2D displacements or the vertical displacements are going to be a really easy way to show where things are settling and that severity. So it gives somebody a very quick understanding of what's going on the site without having to be an expert on anything. So you don't need to be a surveyor to understand that these vertical displacements are red. It makes it very quick and very, very easy. You can also do things like overlay images in the background. And so if you have site plans and site drawings, as long as they're geolocated, you can upload them and give it like a transparent layer on the map. And then you can very easily show like, okay, the tunnel design goes right under the building here. And that's why we're seeing these movements here, or not seeing movements there. So you can show displacements or not displacement related to whatever is happening on the site. You can also make your own kind of custom views in here. So we have, so this is like a static image of our office. I just took it on my phone and then uploaded it to T4D and then dragged and dropped some sensors in place. But this could also be a webcam feed from the site. So if there's cameras on site, you pull those feeds into T4D and then overlay your target information on top. And then when you hover over, it gives you an interactive kind of live view of what's going on. So we have our scatter plot here showing kind of the most recent data sets. And then our just charts showing displacements over time. So a really quick way to kind of get a good understanding of what's moving, where it's moving, and to the disparity. You can also do things like build in what's called a composite view, which is what we kind of think about as a dashboard view. This is a really good way to give somebody a quick overview of the site. So it gives you that custom view, some of the charting options, and you can do like a system status to show what sensors are online, what sensors are offline, the alarm intervals and alarm reports. The great thing about these custom views and these composite views is that they're easy to set up and should be fairly easy to look at. You can also publish these to an open web page. So everything in T4D Web is restricted to your account. People can get set up with accounts and access just as needed and log in whenever they want. But these custom views, you can publish to an open URL and just send that URL out, and you don't need an account for it. So somebody that's not interested in logging in or getting reports or getting alarms can just bookmark this to the web page and log in and view it kind of as needed. This is a good option for somebody that's like a building owner. So maybe they're own the apartment building that's next to the construction site that you're working on. You just send them this and they can log in whenever they want and check in and see it. So if they think that something's happening, they can open the page up and verify that the construction hasn't influenced their building at all. Or if it has, and get an understanding of why that's happening. And then they don't have to be involved with the monitoring system. They don't have to get the reports every day. They just check in whenever. You can also build in your own custom analysis. The analysis can be something like a chart or scatter plot, or if you have wind data, it can be like a windrows or a precipitation overlay. So there's a lot of different options on how that data is displayed. This one shows in the background our alarm status. So kind of our alert levels and how that just, or how our thresholds kind of overlay with the prism data. Then we have all of our just 2D prism moving on. So fairly easy to set up, simple intuitive chart. You can also do things like integrate multiple data sets onto a single chart. So here we have our tilt data with our total station 2D displacement data to really kind of integrate these things together. So on the roof at the office, we have everything set up on these big metal columns. And those columns move around throughout the day. So the sun hits them and the temperature influences them. They just kind of walk in a big circle. And so having something like a tilt meter on top of that data gives you a really good understanding of not just how much it's moving, but also why it might be moving, because that column itself is tilted. When you have really noisy data like this too, when I say really noisy, it's moving like a millimeter or two. You can overlay your trends on top of the chart. So when you have this big sinusoidal kind of daily effect, sometimes it can be hard to extrapolate a trend. So T4D can automatically overlay that trend on there for you and just show, especially on something like a railway that's going to move with the temperature quite a bit. Hopefully it's moving the same every day, so you can overlay that vertical kind of trend and show it's not settling or it is settling or it's got some sort of typical behavior. So it makes it a lot easier to understand what could be happening. There's also a feature in here called visual inspection. The idea with visual inspection is that we can so I'm going to take a second to load. So the total stations all have integrated cameras on them, at least all the S-series total stations that we make, or most of them, I should say. And the idea is that when you turn to a target location, the system knows that you want a photo, so it's going to record a photo with every round measurement. And then T4D can display those photos over time to show you kind of real-time changes. I don't want to overpromise what the cameras can do. So this camera is actually from an SX10 that we were testing for a while. So it's a little bit of a higher resolution image. The camera on the S series is really good for site conditions, but maybe not good for like crack detection and actually picking out minute features. But especially when you have a noisy site and you're missing prisms, maybe because a truck is moving in the way constantly, it's a really good just historical record keeper and kind of sanity check. So you can open up that camera feed. You can view the historic photos and say, we've missed the prism measurement for the last week because somebody parked their truck in there and then went on vacation. So it makes it much easier to kind of manage this and kind of be a little bit more autonomous. All of the analyses that you build in the system can be sent out as automated reports as well. And so you can have as many different reports in the system as you need. And they can send out whatever data sets to whoever needs to get them. So you can very easily have a report that is, an Excel sheet that shows the actual prism 3D coordinates over time. and have that emailed out once a week to the surveyors who are working, you know, adjacent to the project, or engineers that need specific data for other work that they're doing. And you can have something as simple as email the charts out at 8 a.m. before work starts, so that somebody can go in and verify everything's all still looking good, and you can go into the site and not worry about it. The reports can be, again, sent to any set of users. So in T4D, you can have as many accounts as you need in here as are required by the site, essentially. And all the accounts can have different roles and permissions. So everybody can be set up with their own kind of level of access. And so if you have somebody that only wants to come in and see the data and receive the reports, but not have to configure anything or get trained up on how to make alarms or make any changes by accident, they can have read-only access, log in and view everything, but not make any changes. You can also have somebody that can come in and make their own changes. They can come in and have their own set of reports and alarms that are only assigned to their account. They can make all those changes, run reports whenever they want, and pull data as needed, but they can't make the site-wide changes. And then you can have somebody with an account that can come in and be like a site-wide admin, where they're resetting passwords and changing those alarm settings and adding accounts and being kind of that super user, and really anywhere in between. You can also do things like configure a custom role, so it might be a little bit hard to see. But this is the features matrix for T4D Web. And so if you need somebody to come in and have a very specific set of tasks that they do, an example I give sometimes is like an IT person who wants to be able to come in and reset people's passwords and add accounts, but they have nothing to do with the actual monitoring data. They can come in and have read-only access for everything but the accounting page. And then when they log in, they only have the buttons that they want to click, and you don't have to worry about accidentally changing alarm settings. Like that. You can also run multiple project sites in a single instance of T4D. The one limiting factor of T4D is that it can only use one coordinate system at a time. So you can't manage, like, you know, a project in Utah and a project in California all using state plane. But you can manage all projects across Utah using Utah state plane coordinates in a single instance of T4D. And each one of those projects can have its own bespoke set of sensors and bespoke set of accounts that are kind of assigned to it. So if you were subcontracting for Qt and you're doing a big rail project, and then you have another project with Walsh who's doing a gigantic highway project, you can have different projects in there and have them all kind of managed in a single system. Do you guys have any questions on T4D? Okay, let me show the rail data too. Have you guys ever used or like gotten data from a monitoring system like this, or even not monitoring system, but another kind of data hosting site as you like worked on projects? So this is the first time you've seen something like this. Cool. I guess what are some of your initial thoughts before I dive back into the data sets? Overwhelming, underwhelming. Does it seem useful? Like, would you be able to host this and deliver data this way instead of emailing out Excel sheets and data sets?
Depends on the project. If RailPros is involved, no. You just have to send them and your Excel data every day or whenever it's required, depending on the what period of the project you're in.
Interesting. So there are also different, I guess, editions of T4D. So it's similar to the way the TDC licenses are built out. So we have what's called T4D Advanced, which includes the web platform and T4D Control and all the geotechnical integrations and like the full sensor suite. And that's like 90% of the deployments that we do for monitoring is with T4D Web and the whole system. But there's also an edition of T4D called T4D Field. That's a pared back version, so it doesn't have T4D Web. It's just the control side. So you can do the automated total station, automatic geodetic adjustments, and then some basic alarming and integrity features. And then it just exports to a CSV sheet or an Excel sheet, and FTP pushes that out to something. And so you can use that as a way to kind of get these processed coordinates out of it, export it to an Excel sheet, and then set that up on a separate email thing to be sent out kind of on a schedule. So there are options to kind of pare back and lower the cost. So you don't always have to install like a full web page node in the folder. On the rail side, so you see this little rail monitoring module, that's all it really is. When you go through and configure it, it is a little bit of work to go through and make your changes and upload your as-built. But once all the data is in T4D, it's all kind of automatically calculated and done for you. You can see there's a bunch of different ways to have your rail segments in here. So you can have multiple rail segments for a single project or split them across multiple projects. You can view data either as a chart by chainage. The chart by chainage is going to give you the actual geometry of the rail as you go down your railway. So give me a second to load. It always takes longer when you show me something. So you can see this is our actual rail geometry as we go down our track. So the chainage represents, you know, the meter 2.5 of the rail and meter 5 and meter 8.4. So different track locations as we go down. And then on the bottom here, we have a bunch of different timestamps. And so you can choose one that goes back in time. So there we go. So you can start to see it deviate at a particular spot. So then you can overlay a bunch of different epochs on a single chart. And then these charts are actually what's sent out as the report. And so somebody that's used to seeing rail data presented this way is going to be really, really happy to get a chart that shows the chainage, shows the twist, and a lot of your vertical displacements, horizontal displacements for your left and right rail. So really specific parameters around. You can also show your charts over time for a particular chainage. So if you wanted to zoom in on one side and say, here's all of our data for the last, here are the timestamp here, but few days. Data is being taken every few minutes, and then you can go down your rail here. So here's our actual rail section. We can go through our changes and show different sections. So it makes it much easier to show that data in a way that makes sense to whoever really needs to see it. You can also use all these different geometry settings in your alarms. So as soon as these rail sections are created, there's going to be sensors essentially associated with those rail parameters. And so when you go and configure your alarms, you can say, I want my alarm threshold to say, if the cant goes under 6 millimeters, then that alarm goes off. So that way you're getting alarms based on the change in the actual rail and not just on those prism displacements. Any questions on T4D Rail?
Is that a separate module from the basic T4D web?
It is. It's an add-on, and so it's the T4D base license. So you have to get T4D Advanced or T4D Geotechnical if you're only doing tilt meters, and then you add on that rail module on top of it. We're also always happy to give demos, and so if you're unsure if it's going to actually work for the project and give what you need, and maybe people aren't asking for it, we're more than happy to give a 30 or 60-day demo if you're using T4D in a rail track, and then if it works, great, you can buy it and keep using it, and if not, that's okay too. Great. Well, nothing wrong with ending a few minutes early for you guys.
So do you guys think this is too complicated to just like figure out? Like, or, you know, use on a day-to-day basis? Because, you know, we could give it to UI people to try and make it simpler too.
Having used it, I think the setup was a little complicated. Which is how I ended up talking to you over the phone so many times.
Yeah.
But once it's set up, it just does the work for you. Like right now, we're monitoring a rail on a bridge and 2 hours outside of Reno. So I got to send somebody up there once a week to download the data, the data collector that somebody on site's been capturing.
Yeah.
He brings it back. I drop it into TBC, spit it out to a spreadsheet, format it, and then send it off.
Yeah.
So that's a couple hours a week that when this is set up, I don't have to do. And when this is set up, that would be a couple hours a day.
Yeah.
If I hadn't used this. Plus a full-time surveyor.
Exactly.
Yeah. The problem that we've had is, you know, a typical customer like Roadrunner, they get a project where they need to do monitoring. And so it's, how do I justify getting something like T4D or a new S9 or the Guido rail system or something like that. And we had this experience with Great Basin. They are a very similar company to like Foresight or Roadrunner, and they had a monitoring job. They got the T4D. The cool thing about T4D is that you can get it in just a year subscription, or you don't have to. It's not like a perpetual license. And when they got finished with that project, they pulled it all down, and now they have that for the next monitoring project that they get. And so I agree that the first time that Great Basin set it up, they got whatever it was, the 1 day of training online, and that was like mandatory. They had to have that. But once that was in place, then the system just kind of ran. And the cool thing about it is that now they at least have that under their belt, and they use the S9 every day as a regular robot. So the Prism. So I just think it's that initial barrier of entry. If you know that you can use it for other projects, possibly.
For sure. And we found it typically takes like a day and a half is usually a good kind of guiding thing, or 2 days, depending on site access and stuff, to do the hardware installation, get T4D installed, and then kind of get it configured. And there's always a little bit of follow-up to kind of get things dialed in and do some revisits and checks. But it's good to think that you would need a good 2 day investment to get it spun up and kind of learn it and get it running.
Oh yeah.
Do you think it's like a template that, you could edit as you went on and have it, cater to your own site specifications? Do you think having a template to start off with would have made the process easier?
For us, we started so late in the game, it was get it here as fast as you can, and as soon as it shows up, we're gonna try to install it, which is why we had to call Roland so many times, because we weren't prepared for it when we got it. And as soon as we got it, we needed to use it. So instead of setting it up at our office, we set it up at a remote site where we had low phone reception.
Yeah.
And we had to drive down the hill to make phone calls. It was a bad scenario, but it was because we did it at the last second instead of having it prepared.
Yeah, we've all been there.
It happened, yeah.
For anyone else who's just seeing this, maybe for the first time, do you think maybe having a template would help out?
Well, I know that whenever we quote a monitoring system, we always get Trimble involved right from the very beginning, because things have changed. There's new softwares, new, accessories that are available that we don't know about. And so we want to make sure that we quote it right. And so Trimble's really involved in these deals. Hopefully it won't be that way forever, but so like what you were describing, that sounds like that's the experiences that we've had as well.
I was curious about the alarms. Are they just email alarms, or?
It's email, SMS, and batch files. And so batch files are really used on like mine sites and dams. Sometimes we have to like sound an alarm. And so it can run a Windows batch file and execute kind of whatever you.
Water treatment plant is right below the dam, and the people down there want an alarm.
Yeah, sure. A true alarm, not an email that can miss.
Yeah, an email that might come and go.
SMS with that.
Yeah, and missing a text in it.
That was super helpful for us to have the alarms, because I had the first alarm would go to me. And then if there was a second alarm, then that would go out to 6 different stakeholders for the project, most of which were Caltrans employees. And when I got the first alarm, I would log in and try and figure out what was going on. So that usually by the time the second alarm came up, I would have an answer that I could send everybody, hey, don't worry about this false alarm, one of the prisms is blocked. Something that simple. The way it was set up, which his counterpart Dallas helped me with, the first alarm allowed me time to have an answer when the phone started ringing. Hey, why is there an alarm? Is somebody up there? Is the bridge falling down? No, just sensor got blocked. So to ease everybody's concerns, that was super helpful.
Yeah, I guess it'd be bad if we sounded an alarm and it was just a sensor blocked. They're evacuating the building.
Yeah, true.
So I guess this, you can access this on your phone or whatever like that too, because it sounds like if you're getting those notifications, you need to be able to
Yeah, you
get to it in a.
The one feature that doesn't work on a mobile phone is that composite view where you have all those different kind of dashboards in there, just because it looks terrible. Everything else works on the phone, so you can view the charts and the alarms and the analysis and stuff like that, so you can always log them.
And as I recall, the M1, which is the piece that attaches to the total station, that has a web UI, so you can control the M1 with your phone from the site.
Yeah, exactly. So that helps a lot. One, in the initial setup, because you can check the total station and do a bunch of stuff when you're there on the site and make sure things are online and working. A lot of times too, what we find is people will plug the M1 in, put the total station up high, and then sit down on the ground and use their phone with the camera feed and actually add the targets that way. So it's like kind of having like a remote data collector. So this is our M1 in Colorado. You can log in the M1 kind of at any time and do things like turn the camera on and control it and add targets, do that same check. It's super useful just to have the total station accessible. Perfect. So round is running now, so I just turn the video on. Yep. You can kind of watch the total station go and do its thing. The video quality is downsampled a little bit on the M1 just to make sure it doesn't take a bunch of bandwidth and slow the whole thing down. But you can like zoom in and see a pretty fair amount of detail.
How difficult is the software that you need to use on the data collector?
This is it. It's super easy. And so it's just a few kind of main buttons. You can see the laser turn on. So if I stop the round, after it's done, you can turn the camera on like it is now, and anywhere you click on the camera feed, it turns the total station to it, and then has like the search and auto lock and change face functions. And so you get close to the target, search for it, and locks on, and then you can measure it and add it, and kind of build around out that way. Once you've gone through and done the initial setup in T4D, like everything automatically syncs back and forth. So the first time you set it up, you do have to go to T4D and like tell it what you want as the backsides and input some of the coordinate information to make sure it's got all the good geometry. Once that's set up, it's kind of an auto sync between the M1 and T4D back and forth. And so if you add a target into the M1 after a round measurement, it'll automatically import that into T4D. So it makes it really easy then to come in and add things later on when I happen, like access the server and log into TeamViewer or remote desktop and go through the whole interface. So even if I just turn like the laser on, we should see a strong reflection. Yep. And so even just something as simple as that's a really good way to check, even if like the prisms are good. And so if you know the prism's in a location and it's good and everything's fine, you can turn to it, turn the laser on and see if you get a reflection, and if not, it's time to clean. So it makes that maintenance super easy to kind of manage. You can also check the level, which, as simple as it seems, can fix a lot of issues. A lot of times the total station will go out of level and somebody will not realize it, and they'll try to run the rounds over and over and over again and think the whole system is broken, when really somebody just needs to go out there and twist the knobs a little bit. Yeah, so it's a fairly easy interface to use. Like you can have somebody who's not a surveyor go out and set this up as long as they know how to basically use the total station. And then they don't need to know the backsides and the geometries and the coordinates and how to set it up and stuff. They can just do it this way. And then in T4D, because it's kind of a separate interface, you guys can then log in remotely and like configure the actual information. The nice thing about having the data backfill is you can also do that for the initial setup. So if you're out there like on a Friday afternoon, somebody can set it up on a Friday afternoon. It can run all weekend, and then on Monday morning, you get to the office, come in, log in, and then configure it, and you can import all the round information from the weekend before, and then process all that data and kind of use it through that setup. So it makes it just that much more flexible when you go and deploy.
So you said that you could have different sites, but they have to be the same coordinate system.
Mm-hmm.
So I could get just one license of this and monitor 5 dams as long as I'm all right here.
Exactly, yeah. And the way the license is built is that you have your base license, and then we have what we call sensor nodes that go on top of it. And so it'll scale with your system as it kind of grows. And so the base license comes with essentially one of each, so one total station, one GNSS, and 5 geotechnical nodes. And so you can just get started that way. And then you can add in a second site with one total station and 150 geotechnical sensors and just pay for what you use. And that way it's not some huge overhead cost for a system that's only doing.
I was thinking because a lot of ours wouldn't be automated. It would be us just coming back and then using this system as the monitor, as you know, the parts and things. So run up, get the data, upload it.
The manual upload in T4D for total stations is free. And so as long as you have a base license, you can upload manual total station data and it doesn't consume any nodes. The geotechnical sensors will consume nodes. And so if you're using like a CSV import or a manual upload, you do have to have the right number of sensor nodes. But if you're just doing manual total station data, you can just pay for a base license of T4D and then use it to manage all your monitoring data without having to buy individual total stations and stuff.
Yeah, that's why I was seeing more just using it to manage my data, just because I hand it off to an engineer and I have a feeling it gets lost.
There's actually,
then he calls me up and says, "Now, do you have that data that you took 5 years ago?"
It could be right here.
Yeah.
There's an edition of T4D called T4D Access that's made for that manual data integration. So it's the backend, it's T4D server and it's T4D advanced, but there's no connection to live real-time total stations. So you can use like a post-processing engine and scan for Trimble access files and import them automatically that way, or manually upload like the Excel templates into T4D web. So exactly what you need.
So if multiple coordinate systems are a requirement for your project, there are kind of back-end workarounds to be able to do that as well. But you have to talk to your IT team who create like different instances of T4D. So it's a little bit, it can be complicated to do it, but it is possible and something we're working on.
For sure.
Do you know is it going to be compatible with I don't know if you know for the new data, state of Utah is doing like hundreds of low distortion projections. You know, it'll end up being compatible with those.
It will be, yeah. So it uses the Trimble just coordinate system manager, which has had that on the radar for forever. So as soon as the coordinate system manager is updated, T4D's got the same system.
So you have to use like a state link coordinates. It's a local site.
You can use a local site, but you kind of have to commit to one or the other when you go into a project. You can change the coordinate system from local to state plane and vice versa, but you wouldn't want to do that with like a running system. So you want to wait until that project's over. Right. But you can use like just a local estimation, even with big coordinate systems.
So what part of the system is hardwired? What part is broadcast like with radio? So I know that the set top has to be hardwired to the total station.
Yep.
But everything else essentially is just radio communication to the set top, right?
So the M1, the set top only controls the total station. There's actually a different geotechnical gateway for those wireless sensors. Okay. And so the wireless sensors, the data loggers in particular, hardwired to the geotechnical sensors that are plugged in the ground. And then they're wireless to the gateway. The gateway needs a power source and internet connection. So it's got that internal modem and Ethernet port to make that just a flexible kind of deployment. But you do need to plug it into a power source, whether it's a wall outlet or a solar kit. So that would be a hardwired connection. And then wireless, obviously, from there to T4D. GNSS kind of the same. It's a wired connection from the antenna to the receiver. Then the receiver needs power and comms. They also have built-in modem, so it's SIM card and usually solar. And that's also wireless link then back to T4D. The tilt meters are completely wireless, so those just drop in place and ready to go.
Questions from the people online?
Any chats? Oh yeah. Andrew, a few minutes ago, said he found the real challenge is educating and convincing the client the value of the added cost. Andrew, does that mean the value of the added cost when in terms of like initial investment for the automated system or the added cost for like T4D Web and all the other tools?
Yeah, it just depends on the project a lot of times, but you're adding, a ton of prisms and this kind of thing. And more specifically, what I was speaking of was the online portals, though. Just educating the client about learning a new system that they have to use to get to the data and look at the data. A lot of times there's just been a lot of inertial, here you can go to here and get this, but then you're going to add that into your estimate, and that adds to the bid on the project. So it's just that kind of give and take there. Is it convincing them, that this is actually worth their time and money. So
Right, that makes
it's
sense.
just, yeah.
Yeah, that is a tricky one, because if a client doesn't want to use technology, it's hard to convince them that technology can help. Even though we know that it does. So
Right.
if that's the
Yeah.
case too, we're always happy to back you guys up, and we can get on the call with Monson and your clients, kind of walking through the system and how it works. And then if it comes down to it too, we can always pare the system back and just give them the Excel sheets out of something like T4D Field that does those calculations. But we could secretly give you guys a T4D Advanced demo, so you can kind of give them the reports and give them the automation and show them how it works and just already be using it. And then maybe it's an easier thing to convince them of next time. But we're ready to help however you need.
Appreciate that.
Welcome. Yeah.
Thank you guys.
Yeah, thank you guys for coming. I know it's a lot of time, so appreciate it.
And a lot of info,
Yeah.
like Regina says.
Yeah.
Thank you guys for your time.
Absolutely,
And the
yeah.
information.
Thanks for the people online as
Yeah,
well.
thank you, everybody. And the owls.
Yeah.